This is a conversation between 1-minute coder and ChatGPT. I want to be a web developer. Which language should I learn first? If you want to become a web developer, it's recommended to start by learning HTML, CSS, and JavaScript. These three languages are the core building blocks of any website or web application, and they work together to make the visual and interactive elements of a web page. HTML is used to make the structure of a web page, including headings, paragraphs, and lists. CSS is used to style the page, controlling the colors, fonts, and layout. JavaScript is used to add interactivity and functionality, allowing users to interact with the page and perform actions. Once you have a good understanding of these languages, you can then move on to more advanced topics such as web development frameworks, back-end programming languages, and database management systems. But starting with HTML, CSS, and JavaScript is a great foundation for becoming a web developer. There are many resources available online to help you learn these languages, including tutorials, courses, and documentation. With practice and persistence, you can master these languages and begin your journey as a web developer. Good luck! What is HTML? How would you explain this to someone just starting out? HTML stands for Hypertext Markup Language. It's a language used to make the structure and content of web pages. Imagine a web page as a building, and HTML is the foundation and framework that gives the building its structure. HTML uses a series of tags to define elements such as headings, paragraphs, images, links, and forms. For example, to make a heading, you would use the tag. These tags tell the web browser how to display the content of the page. When you visit a website, your web browser reads the HTML code and uses it to display the web page on your screen. In summary, HTML is a language used to make the structure and content of web pages. It uses a series of tags to define elements such as headings, paragraphs, images, links, and forms. Understanding HTML is essential for anyone who wants to become a web developer. What is CSS? How would you explain this to someone just starting out? CSS stands for Cascading Style Sheets. It's a language used to style and lay out web pages. Imagine a web page as a building, and HTML is the foundation and framework that gives the building its structure. CSS is like the paint and decoration that gives the building its style and personality. CSS uses a series of rules to define the style and layout of HTML elements. For example, you can use CSS to set the font size and color of text, adjust the spacing between elements, and make complex layouts using grids and flex boxes. When you visit a website, your web browser reads both the HTML code and the CSS code and uses them together to display the web page on your screen. In summary, CSS is a language used to style and lay out web pages. It uses a series of rules to define the style and layout of HTML elements. Understanding CSS is essential for anyone who wants to become a web developer and make visually appealing and engaging websites. What is JavaScript? How would you explain this to someone just starting out? JavaScript is a programming language used to add interactivity and dynamic behavior to web pages. Imagine a web page as a building, and HTML is the foundation and structure, and CSS is the paint and decoration. JavaScript is like the electricity that powers the building and makes it come to life. JavaScript can be used to make animations, respond to user input, validate forms, and interact with back-end systems. For example, you can use JavaScript to make a slideshow that automatically cycles through images, make interactive forms that validate user input, or update parts of a web page without refreshing the entire page. When you visit a website that uses JavaScript, your web browser reads the JavaScript code and uses it to add interactivity and dynamic behavior to the web page. In summary, JavaScript is a programming language used to add interactivity and dynamic behavior to web pages.
This is a conversation between 1-minute coder and ChatGPT about HTML, CSS, and JavaScript. Can you tell me about HTML, CSS, and JavaScript? Certainly. Here's a brief overview of each. HTML, Hypertext Markup Language, is a markup language used for making web pages. It provides the structure and content of a web page through various elements such as headings, paragraphs, lists, images, links, and more. HTML is responsible for organizing the content of a web page and providing a structure that can be understood by web browsers. CSS, Cascading Style Sheets, is a stylesheet language used to describe the visual appearance of a web page. It is used to control the layout, colors, fonts, and other visual aspects of a web page. With CSS, you can separate the presentation of a web page from its content, making it easier to maintain and modify the visual aspects of a web page. JavaScript is a scripting language used for making interactive and dynamic web pages. It is used to add behavior to a web page, such as responding to user interactions, updating content dynamically, and manipulating the page's appearance in real time. JavaScript is often used in combination with HTML and CSS to make complex web applications. AvaScript is a client-side scripting language, meaning that it runs on the client's computer rather than on the server. This allows it to interact with the user and the web page in real time, without requiring a page reload. JavaScript can also be used on the server side with technologies like Node.js. Some common uses of JavaScript include form validation, making interactive web applications and games, dynamic page content updates, and more. JavaScript is a powerful and versatile language that is widely used in web development. Together, HTML, CSS, and JavaScript form the core technologies used for making web pages and web applications. They work together to provide the structure, style, and behavior of a web page, making rich and engaging user experiences. To summarize, HTML provides the content and structure of a web page, CSS provides the visual presentation and layout, and JavaScript provides the dynamic behavior and interactivity. It's worth noting that while HTML, CSS, and JavaScript are often used together in web development, they are also distinct languages with their own unique features and uses. HTML is focused on making content and structure, CSS is focused on visual design and layout, and JavaScript is focused on making interactivity and dynamic behavior. Each language has its own syntax and rules, and while they can all be used to make a web page, they are used for different purposes. Overall, understanding HTML, CSS, and JavaScript is essential for anyone looking to get into web development, as they form the foundation of modern web technologies. By mastering these languages, you can make beautiful and engaging web pages and applications that provide a rich and seamless user experience. In addition to their individual roles, HTML, CSS, and JavaScript also work together in various ways to make modern web applications. For example, CSS can be used to modify the appearance of HTML elements based on user interactions, while JavaScript can be used to add or remove HTML elements from the page in real time. JavaScript also enables developers to make complex web applications that use features such as asynchronous data loading, which allows for faster page rendering and better user experience. This is particularly useful in applications that need to load large amounts of data or that require real-time updates, such as social media platforms and chat applications. It's worth mentioning that while HTML, CSS, and JavaScript are the core technologies used for web development, there are many other tools and frameworks available that can enhance their capabilities and make web development more efficient. These include libraries like jQuery and React, which provide additional functionality and make it easier to write complex web applications. In conclusion, HTML, CSS, and JavaScript are essential tools for web developers, providing the foundation for making modern, interactive, and engaging web pages and applications. While each language has its own unique features and uses, they work together to make a seamless user experience that is responsive, dynamic, and visually appealing. Furthermore, HTML, CSS, and JavaScript are constantly evolving, with new versions and features being released regularly to improve the web development experience. For example, HTML5 introduced new elements and APIs that make it easier to make multimedia-rich web applications, while CSS3 introduced new properties and capabilities for advanced layout and animation. JavaScript has also seen significant growth and development, with new frameworks and libraries being released regularly that make it easier to write complex web applications. Some popular JavaScript frameworks include Angular, React, and Vue.js, each with its own unique features and strengths. Overall, the continued evolution and improvement of HTML, CSS, and JavaScript have made it easier than ever for developers to make modern and responsive web applications that provide a seamless user experience across multiple devices and platforms. As the web continues to evolve, it is likely that we will see even more powerful tools and frameworks emerge that further enhance the capabilities of these core technologies. It's important to note that while HTML, CSS, and JavaScript are essential for web development, they are not the only technologies involved. Other technologies include server-side languages like PHP and Python, databases like MySQL and MongoDB, and web servers like Apache and Jinx. These technologies work together to make a complete web application. It's also important for developers to consider factors such as accessibility, performance, and security when developing web applications. For example, ensuring that a web page is accessible to users with disabilities is an important consideration that involves using proper HTML structure, providing alternative text for images, and ensuring that the page can be navigated with a keyboard. Similarly, optimizing web page performance involves minimizing page load times, reducing server requests, and optimizing images and other multimedia. And ensuring web application security involves implementing measures such as SSL/TLS encryption, input validation, and access controls to prevent unauthorized access and data breaches. In conclusion, HTML, CSS, and JavaScript are essential tools for web development, but they are just one piece of the puzzle. To make modern, responsive, and secure web applications, developers must consider a wide range of technologies and factors, including server-side languages, databases, web servers, accessibility, performance, and security. Additionally, web developers need to have a good understanding of web design principles and user experience, UX, design. Making a visually appealing and user-friendly web page or application is just as important as its functionality. UX design involves designing user interfaces that are easy to use and navigate, and that provide a positive user experience. In the modern web development landscape, there are also a variety of tools and frameworks available that make web development more efficient and effective. For example, content management systems, CMS, like WordPress and Drupal provide pre-built templates and themes that can be customized to make professional-looking web pages without requiring extensive coding knowledge. Similarly, front-end frameworks like Bootstrap and Foundation provide pre-built HTML, CSS, and JavaScript components that can be easily integrated into a web application. This can save developers time and effort, and make it easier to make responsive and visually appealing web pages and applications. Overall, web development is a complex and constantly evolving field that requires a diverse set of skills and knowledge. By mastering the core technologies of HTML, CSS, and JavaScript, as well as other relevant technologies and design principles, developers can make powerful and engaging web applications that meet the needs of modern users. Another important aspect of web development is testing and debugging. It is essential for developers to thoroughly test their web applications to ensure that they work as expected and are free of bugs and errors. This involves testing the application on different devices, browsers, and operating systems to ensure that it works properly in different environments. Debugging is the process of identifying and fixing errors and bugs in the code. This involves using debugging tools and techniques to identify the source of the problem and then making the necessary changes to fix it. Effective debugging is an essential skill for web developers and can help to improve the quality and reliability of web applications. Web development is not just about making web pages and applications, but also about maintaining and updating them over time. This involves ensuring that the web application remains compatible with new versions of browsers and operating systems, and addressing security vulnerabilities as they arise. In conclusion, web development is a complex and multifaceted field that requires a diverse set of skills and knowledge. HTML, CSS, and JavaScript form the foundation of modern web technologies, but developers must also have a good understanding of design principles, UX design, testing, debugging, and maintenance to make successful web applications. By staying up to date with the latest technologies and best practices, web developers can make powerful and engaging web applications that meet the needs of modern users. One point to consider is the importance of collaboration in web development. Web developers often work in teams, and effective collaboration is essential for ensuring that the web application meets the requirements of stakeholders and users. Collaboration involves effective communication between team members, as well as using collaboration tools like version control systems to manage code changes and track issues and bugs. Code reviews, where team members review each other's code, can also be a valuable collaboration tool for identifying potential problems and improving code quality. In addition to collaborating with other developers, web developers also need to work closely with designers, project managers, and other stakeholders to ensure that the web application meets their requirements and goals. Effective collaboration requires a willingness to listen and communicate, as well as the ability to work effectively in a team environment. In summary, web development is a dynamic and challenging field that requires a diverse set of skills and knowledge. HTML, CSS, and JavaScript form the foundation of modern web technologies, but developers must also have a good understanding of design principles, UX design, testing, debugging, maintenance, and collaboration to make successful web applications. By staying up to date with the latest technologies and best practices, and working effectively with others, web developers can make powerful and engaging web applications that meet the needs of modern users. It's worth noting that the field of web development is constantly evolving, and new technologies and techniques are emerging all the time. To be a successful web developer, it's important to stay up to date with the latest trends and developments in the industry, and to continue learning and expanding your skill set. One way to stay up to date is to participate in online communities and forums where web developers share knowledge and expertise, such as Stack Overflow and GitHub. Attending web development conferences and workshops can also be a great way to learn about new technologies and connect with other developers. It's also important for web developers to have a passion for learning and experimenting. Trying out new technologies and approaches can help you stay on the cutting edge of the industry, and can help you develop new skills and insights that you can apply to your work. In conclusion, web development is a challenging and rewarding field that requires a diverse set of skills and knowledge. By mastering the core technologies of HTML, CSS, and JavaScript, as well as other relevant technologies and design principles, and by staying up to date with the latest trends and developments in the industry, web developers can make powerful and engaging web applications that meet the needs of modern users. One area that is worth exploring in more depth is the relationship between web development and user experience, UX, design. As we mentioned earlier, making a visually appealing and user-friendly web page or application is just as important as its functionality. UX design is the process of designing interfaces that are easy to use and navigate, and that provide a positive user experience. One of the key principles of UX design is usability. Usability refers to the ease with which a user can interact with a web application, and encompasses factors such as ease of use, ease of learning, and overall user satisfaction. A web application that is easy to use and navigate, and that provides a positive user experience, is more likely to be successful than one that is confusing or difficult to use. To make a web application that is both functional and user-friendly, it's important for web developers to work closely with UX designers throughout the development process. UX designers can provide insights into how users interact with the application, and can help to identify potential usability issues before they become major problems. In addition to usability, other key principles of UX design include consistency, accessibility, and responsiveness. Consistency refers to the need for a web application to have a consistent look and feel throughout, with consistent navigation, labeling, and visual design. Accessibility refers to the need for a web application to be usable by all users, regardless of any disabilities they may have. Responsiveness refers to the need for a web application to adapt to different devices and screen sizes, and to provide a seamless user experience across all devices. Another important area to consider in web development is security. Web applications are vulnerable to a wide range of security threats, including hacking, malware, and phishing attacks. To protect web applications against these threats, it's important for web developers to follow best practices for security, such as using secure authentication methods, encrypting sensitive data, and keeping software up to date with security patches. In addition to following best practices for security, web developers can also use specialized security tools and services to help protect their web applications. These tools can include web application firewalls, intrusion detection systems, and vulnerability scanners, among others. Overall, web development is a multifaceted field that requires a diverse set of skills and knowledge. By working closely with UX designers, following best practices for security, and staying up to date with the latest trends and developments in the industry, web developers can make powerful and engaging web applications that meet the needs of modern users. Another important aspect of web development to consider is the need for testing and debugging. Web applications can be complex and difficult to develop, and it's not uncommon for bugs and other issues to arise during the development process. To ensure that a web application is functioning properly and providing a positive user experience, it's important to thoroughly test and debug it before deploying it to production. There are several different types of testing that can be used to ensure the quality and reliability of a web application. One of the most common types of testing is unit testing, which involves testing individual components of the application to ensure that they are functioning as expected. Integration testing, on the other hand, involves testing how different components of the application work together. Other types of testing that can be used to ensure the quality of a web application include performance testing, security testing, and user acceptance testing. Performance testing involves testing how well the application performs under different levels of load and stress, while security testing involves testing the application for vulnerabilities and other security issues. User acceptance testing involves testing the application with actual users to ensure that it meets their needs and expectations. Once testing is complete, it's important to address any issues that were identified during the testing process. This may involve fixing bugs or other issues, or making changes to the application to improve its performance, security, or user experience. In addition to testing and debugging, web developers also need to be proficient in maintenance and support. Web applications are not static entities, they need to be regularly updated and maintained to ensure that they continue to function properly and meet the needs of users. Maintenance and support can involve a wide range of tasks, including updating software, fixing bugs and other issues, and responding to user feedback and requests. Web developers also need to be familiar with deployment processes, and need to be able to deploy updates and changes to the application without causing disruption to users. In conclusion, web development is a complex and challenging field that requires a diverse set of skills and knowledge. By thoroughly testing and debugging web applications, ensuring that they are secure and user-friendly, and providing ongoing maintenance and support, web developers can make powerful and engaging web applications that meet the needs of modern users. Another important area of web development is search engine optimization, SEO. SEO is the process of optimizing a web page or application to rank higher in search engine results pages, SERPs, with the goal of increasing traffic to the site. There are several factors that search engines use to determine the relevance and authority of a web page, including the quality and relevance of the content, the structure and organization of the page, and the quality and relevance of the external links pointing to the page. SEO involves optimizing these factors to improve the likelihood that the page will rank higher in search engine results. Some of the key strategies used in SEO include keyword research, on-page optimization, and link building. Keyword research involves identifying the keywords and phrases that are most relevant to the content on the page, and incorporating them into the page in a way that is natural and relevant. On-page optimization involves optimizing the content, structure, and organization of the page to make it more search engine friendly. This may involve optimizing page titles and meta descriptions, using header tags to structure content, and incorporating relevant keywords throughout the page. Link building involves building high-quality external links pointing to the page. This can help to increase the authority and relevance of the page, and can improve its ranking in search engine results. In addition to these strategies, web developers also need to stay up to date with the latest trends and developments in SEO. Search engines are constantly updating their algorithms, and what worked well for SEO in the past may not be effective today. By implementing effective SEO strategies, web developers can improve the visibility and discoverability of their web pages, and can attract more traffic and potential customers to their sites. In summary, SEO is an essential aspect of web development that can have a significant impact on the success of a web page or application. By implementing effective SEO strategies, web developers can improve the visibility and discoverability of their pages, and can attract more traffic and potential customers to their sites. Another important aspect of web development is accessibility. Web accessibility refers to the design and development of websites and applications that can be used by people with disabilities, including those who are blind, deaf, or have mobility impairments. Accessible web design involves making content that can be easily accessed and understood by people with disabilities, as well as providing alternative ways of accessing content for those who may have difficulty with traditional navigation methods. Some key strategies for making accessible web content include using alternative text for images and other non-text content, providing captions and transcripts for videos and audio content, ensuring that forms can be navigated using keyboard-only inputs, and ensuring that the website can be navigated using screen readers. Web developers should also consider the use of assistive technologies, such as screen readers and keyboard-only navigation, when testing and developing their websites and applications. This can help to ensure that the site is accessible to users with disabilities, and can provide valuable feedback on the effectiveness of the site's accessibility features. In addition to making web content accessible to people with disabilities, accessible web design can also improve the overall usability and user experience of the site for all users. For example, clear and concise content, well-organized pages, and easy-to-navigate interfaces can make the site easier and more enjoyable to use for everyone. In summary, web accessibility is an important aspect of web development that involves making websites and applications that can be used by people with disabilities. By incorporating accessibility features into their designs, web developers can improve the usability and user experience of their sites, while also ensuring that they are accessible to all users, regardless of their abilities. Another important aspect of web development is security. As more and more information is shared online, web developers need to take steps to ensure that their websites and applications are secure and protected from cyber attacks. Web security involves a range of strategies and techniques to protect the website and its users from potential security threats. This includes implementing secure authentication processes, securing the website's infrastructure and servers, and encrypting data transmissions between the website and its users. One important security technique is the use of secure protocols such as HTTPS, which encrypts data transmissions between the website and its users, making it more difficult for hackers to intercept and steal sensitive information. Web developers should also stay up to date with the latest security threats and vulnerabilities, and take steps to mitigate potential risks. This may involve conducting regular security audits and vulnerability scans, and implementing security patches and updates as needed. In addition to protecting the website and its users from external threats, web developers also need to consider the security of the data that is stored on the site. This may involve implementing secure data storage and backup systems, as well as implementing data access controls to ensure that only authorized users can access sensitive information. Overall, web security is an important aspect of web development that involves implementing a range of strategies and techniques to protect the website and its users from potential security threats. By prioritizing security in their web development process, web developers can help to protect sensitive information, prevent data breaches, and maintain the trust of their users. Another important aspect of web development is search engine optimization, SEO. SEO is the process of optimizing a website and its content to rank higher in search engine results pages, SERPs, for specific keywords and phrases. SEO involves a range of techniques and strategies, including keyword research, on-page optimization, link building, and content creation. Keyword research involves identifying the words and phrases that people are using to search for content related to the website's topic, and incorporating those keywords into the website's content and metadata. On-page optimization involves optimizing the website's structure, content, and metadata to make it more search engine friendly. This may involve optimizing the website's URL structure, using header tags to organize content, and ensuring that the website's content is relevant and valuable to users. Link building is another important aspect of SEO, and involves building high-quality links from other websites to the website being optimized. This can help to increase the website's authority and trustworthiness in the eyes of search engines, which can improve its ranking in SERPs. Content creation is also a key aspect of SEO, as search engines favor websites that regularly produce high-quality, relevant content. This may involve making blog posts, articles, videos, and other types of content that are valuable and useful to the website's target audience. By incorporating SEO techniques and strategies into their web development process, web developers can help to improve the visibility and ranking of their website in search engine results pages, which can help to attract more traffic and potential customers to the site. Another important aspect of web development is accessibility. Web accessibility involves designing websites and applications in a way that enables people with disabilities to use them easily and effectively. This can include implementing features such as screen readers, text-to-speech tools, keyboard navigation, and other assistive technologies that make it easier for people with visual, auditory, physical, or cognitive disabilities to access and interact with web content. Web developers need to consider the needs of all users when designing and developing websites and applications. This may involve following established accessibility standards and guidelines, such as the Web Content Accessibility Guidelines, WCAG, developed by the World Wide Web Consortium, W3C. WCAG provides a set of guidelines and principles for designing websites and applications that are accessible to people with disabilities. This includes ensuring that web content is perceivable, operable, understandable, and robust, and providing alternatives for non-text content, such as images and videos. Web developers also need to test their websites and applications for accessibility and usability, and make adjustments and improvements as needed to ensure that they are accessible to as many people as possible. By prioritizing accessibility in their web development process, web developers can help to ensure that everyone, regardless of their abilities, can access and use their websites and applications effectively and efficiently. This can help to increase inclusivity and diversity, and provide equal access to information and services for all users. HTML, Hypertext Markup Language, is a markup language used for making web pages. It consists of a set of tags and attributes that define the structure and content of a web page. HTML provides a way to add headings, paragraphs, lists, images, links, and other elements to a web page. CSS, Cascading Style Sheets, is a style sheet language used for describing the presentation of a web page. It allows web developers to separate the presentation of a web page from its content, which makes it easier to maintain and update the design of a website. CSS provides a way to define the layout, colors, fonts, and other visual aspects of a web page. JavaScript is a programming language used for making dynamic and interactive web pages. It can be used to add interactivity to a web page, such as animations, form validation, and user interface enhancements. JavaScript can also be used to make web applications and games. In summary, HTML provides the structure and content of a web page, CSS provides the presentation and styling of a web page, and JavaScript provides the interactivity and dynamic behavior of a web page. Together, these three technologies form the foundation of modern web development. HTML, Hypertext Markup Language, is a markup language that is used to make content for the World Wide Web. It consists of a set of tags and attributes that define the structure and content of a web page. The tags and attributes allow web developers to specify the different types of content that will appear on a web page, such as headings, paragraphs, images, links, and more. HTML is a declarative language, which means that the code that is written does not directly control the behavior of the web page. Instead, the code specifies the structure and content of the page, and the web browser is responsible for rendering the page based on the HTML code. HTML is based on a tree-like structure of elements. The top-level element is the HTML tag, which contains the entire document. Inside the HTML element, there are two main sections: the head section, which contains metadata about the document, such as the title and links to stylesheets, and the body section, which contains the visible content of the page. Each HTML element can have attributes, which provide additional information about the element. For example, the img tag has an attribute called src, which specifies the URL of the image that should be displayed. HTML has evolved over the years, and there are currently several versions of the language in use. The latest version is HTML5, which includes many new features and improvements over previous versions. HTML5 provides a rich set of tags and attributes for making modern, responsive, and interactive web pages. Overall, HTML is a fundamental part of web development, and it is essential for anyone who wants to make web content to have a basic understanding of the language. HTML is a markup language, which means that it uses tags and attributes to describe the structure and content of a document. Tags are used to define different types of content, such as headings, paragraphs, lists, tables, and more. Attributes provide additional information about an element, such as the source of an image or the destination of a link. One of the key benefits of HTML is that it is a platform-independent language, which means that web pages made using HTML can be accessed and viewed on any device or operating system that supports web browsing. HTML also provides a way to make accessible web pages, which means that people with disabilities can access and interact with web content. HTML includes a set of accessibility features, such as the ability to add alternative text for images, captions for audio and video content, and semantic tags for headings and other content. In addition to standard HTML, there are also several HTML-based frameworks and libraries that can be used to make web applications and responsive designs. These frameworks, such as Bootstrap and Foundation, provide pre-built templates and components that can be customized to make modern, responsive web pages. HTML is a constantly evolving language, with new versions and updates being released regularly. The latest version of HTML is HTML5, which includes many new features and improvements over previous versions. Some of the new features in HTML5 include support for video and audio playback, drag-and-drop functionality, and new semantic tags for marking up content. Overall, HTML is a critical component of web development, and a solid understanding of the language is essential for anyone who wants to make web content or applications. CSS, Cascading Style Sheets, is a style sheet language that is used to define the presentation of a document written in HTML or XML. CSS allows web developers to separate the presentation of a document from its content, which provides greater flexibility and control over the design of a web page. CSS consists of a set of rules that define how the elements of a web page should be styled. These rules consist of a selector, which identifies the HTML element to be styled, and a set of properties and values that define the style for that element. CSS rules can be defined in an external file, in the head section of an HTML document, or inlined within individual HTML tags. Some of the key features of CSS include layout. CSS provides a range of layout techniques that allow web developers to control the position and size of elements on a web page, including floats, grids, and flexbox. Typography. CSS allows web developers to specify the font, size, and color of text on a web page, as well as other typography-related properties such as line height and letter spacing. Color and imagery. CSS can be used to define the color and background of HTML elements, as well as to specify the size and position of images. Animation and effects. CSS includes support for animation and other effects, such as transitions and transforms, which can be used to make dynamic and engaging web pages. Overall, CSS is a critical component of modern web development, and a strong understanding of CSS is essential for anyone who wants to make visually appealing and functional web pages. Responsive design. CSS allows web developers to make responsive web designs that adapt to different screen sizes and devices, such as desktops, tablets, and smartphones. This is achieved through techniques such as media queries, which allow CSS to be applied selectively based on the characteristics of the user's device. Modularity. CSS allows web developers to make reusable styles that can be applied to multiple elements across a web page or website. This promotes consistency and simplifies maintenance of the code. Cross-browser compatibility. CSS is supported by all major web browsers, which means that web developers can write styles that work consistently across different platforms and devices. In addition to these features, CSS also provides a range of tools and frameworks that can help to streamline the development process. For example, CSS preprocessors such as Sass and Less can be used to write CSS more efficiently, while CSS frameworks such as Bootstrap and Foundation provide a set of pre-built styles and components that can be used to speed up the development process. Overall, CSS is a powerful and flexible language that is essential for modern web development. A strong understanding of CSS can help web developers to make visually appealing and functional web pages that work seamlessly across different devices and platforms. Selectors. CSS offers a wide range of selectors to target specific HTML elements and apply styles to them. It includes simple selectors, such as element selectors and class selectors, as well as more advanced selectors, such as attribute selectors and pseudoclasses. Specificity. CSS uses a system of specificity to determine which styles should be applied to a particular HTML element. This allows web developers to make highly targeted styles that apply only to specific elements on a web page. Inheritance. CSS allows styles to be inherited from parent elements to child elements, which can help to simplify the process of styling a web page. This means that styles applied to a parent element will automatically be applied to all of its child elements, unless they are overridden by a more specific style. Vendor prefixes. CSS provides a way to add experimental or vendor-specific styles to a web page using vendor prefixes. This allows web developers to take advantage of cutting-edge features and functionality that may not yet be fully supported by all web browsers. Compatibility with other languages. CSS can be used in combination with other web development languages, such as HTML, JavaScript, and server-side languages like PHP and Python, to make dynamic and interactive web pages and applications. In summary, CSS is a powerful and versatile language that provides web developers with a range of tools and techniques for controlling the visual appearance of a web page. By mastering CSS, web developers can make engaging, responsive, and user-friendly web pages that are optimized for a range of devices and platforms. Box model. One of the core concepts in CSS is the box model, which defines how elements are laid out on a web page. Every HTML element is essentially a rectangular box, and the box model describes how the size, padding, border, and margin of each box is calculated. Layout systems. CSS provides a range of layout systems that allow web developers to control the positioning and flow of elements on a web page. These include float-based layouts, grid-based layouts, and flexbox layouts, each with its own strengths and weaknesses. Responsive design. With the growing prevalence of mobile devices and varying screen sizes, responsive design has become an essential aspect of modern web development. CSS offers a range of techniques for making responsive layouts that adapt to different screen sizes and devices. Animation and transitions. CSS allows web developers to add dynamic effects to their web pages, such as animations and transitions. These can be used to make engaging and interactive user experiences, or to add visual interest and appeal to static pages. Performance optimization. CSS can have a significant impact on the performance of a web page, particularly in terms of page load times. Web developers can optimize CSS performance by minimizing the use of unnecessary styles, using efficient selectors, and utilizing techniques such as CSS preprocessing and minification. Cross-browser compatibility. While CSS is supported by all major web browsers, there can be variations in how different browsers interpret CSS styles. Web developers must be aware of these variations and test their CSS styles across multiple browsers to ensure consistent performance and appearance. Overall, CSS is an essential tool for web developers, providing a range of powerful techniques for controlling the visual appearance and layout of web pages. With a strong understanding of CSS, web developers can make engaging, responsive, and high-performance web pages that are optimized for a wide range of devices and platforms. Debugging is an essential part of web development, and CSS provides a range of tools and techniques for identifying and fixing problems with styles. This includes browser developer tools, which allow web developers to inspect and modify the styles of elements on a web page in real time. Accessibility is an increasingly important aspect of web development, and CSS can be used to make web pages that are accessible to users with a range of disabilities. This includes techniques such as using high-contrast colors, providing clear and consistent navigation, and using semantic markup to improve the readability and structure of a web page. Print styles. CSS can be used to make styles specifically for printing, allowing web developers to control the appearance of a web page when it is printed out. This can be useful for making printable versions of web pages or for optimizing the layout of printed materials such as brochures and reports. Customization. CSS allows web developers to make custom styles that reflect the branding and identity of a business or organization. This includes custom fonts, colors, and styles that can be used across a range of web pages and applications. Scalability. CSS is a scalable language that can be used to make styles for large and complex web projects. This includes techniques such as modular CSS, which allows styles to be broken down into smaller components that can be reused across multiple pages and applications. Preprocessors. CSS preprocessors such as Sass and Less allow web developers to write CSS more efficiently and with greater flexibility. This includes features such as variables, functions, and mix-ins, which can help to simplify the process of making and maintaining large CSS style sheets. Overall, CSS is a powerful and versatile language that is essential for modern web development. By mastering CSS, web developers can make engaging, responsive, and user-friendly web pages and applications that are optimized for a wide range of devices and platforms. JavaScript is a programming language that is used primarily for web development, but can also be used for server-side scripting and other applications. JavaScript was first introduced in 1995 and has since become one of the most widely used programming languages in the world. Here are some key features and concepts of JavaScript. Object-oriented programming. JavaScript is an object-oriented programming language, which means that it uses objects to represent data and functionality. Objects can contain properties, which represent data, and methods, which represent functionality. Variables and data types. JavaScript allows you to make variables, which can store data values. JavaScript supports a range of data types, including strings, numbers, booleans, objects, arrays, and null and undefined values. Functions. JavaScript allows you to make functions, which are reusable blocks of code that can perform specific tasks. Functions can take arguments, input values, and return values. Control flow. JavaScript provides a range of control flow statements, including if/else statements, for loops, while loops, and switch statements. These allow you to control the flow of execution in your code. Events and event handling. JavaScript allows you to respond to events that occur on a web page, such as mouse clicks, form submissions, and page loads. You can use event handling code to perform actions in response to these events. Document Object Model, DOM. The DOM is a representation of an HTML document as a tree of objects. JavaScript can be used to manipulate the DOM, adding, removing, or modifying elements on a web page in response to user interaction or other events. Asynchronous Programming. JavaScript supports asynchronous programming, which means that you can perform multiple tasks at the same time without blocking the main thread of execution. This can be useful for performing tasks such as AJAX requests or animations. Libraries and frameworks. There are a range of libraries and frameworks available for JavaScript, which provide additional functionality and simplify the process of developing web applications. Popular JavaScript libraries and frameworks include jQuery, React, Angular, and Vue. APIs. JavaScript can be used to interact with APIs, application programming interfaces, which allow you to access data and functionality provided by other web applications and services. Debugging. Debugging is an essential part of web development, and JavaScript provides a range of tools and techniques for identifying and fixing problems in your code. This includes browser developer tools, which allow you to inspect and modify the code of a web page in real time. Overall, JavaScript is a powerful and versatile programming language that is essential for modern web development. By mastering JavaScript, web developers can make interactive and responsive web applications that provide a high-quality user experience across a range of devices and platforms. Error handling. JavaScript provides robust error handling mechanisms to help prevent issues and to detect errors when they occur. These mechanisms include try/catch statements and throwing custom errors. Regular expressions. Regular expressions are powerful patterns that can be used to search and manipulate strings in JavaScript. They are an important feature for working with text data in web applications. Scope. JavaScript has a scope, which defines the visibility of variables and functions in different parts of your code. Understanding scope is essential for writing clean and efficient JavaScript code. Closure. Closure is a concept in JavaScript that allows a function to access variables and functions that are defined outside of its scope. This can be useful for making modular and reusable code. Promises. Promises are a way to manage asynchronous code in JavaScript. They allow you to execute code asynchronously and handle the results when they are available. Modules. JavaScript modules allow you to split your code into smaller, reusable pieces. This makes it easier to maintain and update your code, as well as to collaborate with other developers. TypeScript. TypeScript is a superset of JavaScript that adds optional static typing and other features to the language. It can help to catch errors earlier in the development process and make your code more maintainable. Node.js. Node.js is a JavaScript runtime that allows you to run JavaScript code outside of the browser, on a server or other platform. It has become a popular choice for building back-end web applications and APIs. JavaScript is constantly evolving and improving, with new features and frameworks being developed all the time. By staying up to date with the latest developments in the language and its ecosystem, web developers can ensure that their JavaScript code remains efficient, maintainable, and effective. ES6, ECMAScript 6, is the sixth major release of the ECMAScript language specification, which JavaScript is based on. ES6 introduced several new features to JavaScript, including let and const variables, arrow functions, template literals, and classes. ES modules are a standardized way to organize and share JavaScript code across different files and projects. They are an important part of modern JavaScript development, allowing developers to make modular and scalable applications. Web APIs. In addition to the DOM, JavaScript can also interact with a wide range of web APIs, including the Fetch API for making HTTP requests, the Web Audio API for working with audio, and the Geolocation API for working with location data. Testing. Testing is an important part of web development, and JavaScript has a range of testing frameworks and libraries available. These include Jest, Mocha, and Jasmine, which allow you to write automated tests for your JavaScript code. Performance optimization. JavaScript performance is a critical factor in web development, and there are several techniques that can be used to optimize JavaScript code. These include reducing the number of HTTP requests, minimizing code size, and using techniques like lazy loading and code splitting to improve page load times. Security. Security is also an important consideration when working with JavaScript. Common security issues include cross-site scripting, XSS attacks, cross-site request forgery, CSRF attacks, and injection attacks. Developers can use a range of techniques and best practices to prevent these types of attacks, including input validation, using HTTPS, and sanitizing user input. JavaScript is an incredibly powerful and versatile programming language that is essential for modern web development. By understanding the core concepts and features of JavaScript, developers can make dynamic, interactive web applications that provide a high-quality user experience across a wide range of devices and platforms. Libraries and frameworks. There are a wide variety of libraries and frameworks available for JavaScript that can simplify and speed up the development process. Some popular libraries and frameworks include React, Angular, Vue.js, and jQuery. Cross-platform development. JavaScript can also be used for cross-platform development, allowing developers to make applications that work across different operating systems and devices. Tools like Electron and React Native allow developers to make desktop and mobile applications using JavaScript and web technologies. Debugging. Debugging is an essential part of the development process, and JavaScript provides a range of tools to help developers find and fix errors in their code. The built-in console and debugger statements can be used to print messages and step through code, while browser-based developer tools like Chrome DevTools provide a wide range of debugging and profiling features. Asynchronous programming. Asynchronous programming is a key aspect of JavaScript, allowing developers to execute code in a non-blocking way. This is essential for building responsive and efficient web applications, as it allows multiple tasks to be performed at the same time without blocking the main thread. Functional programming. JavaScript also supports functional programming, a programming paradigm that emphasizes immutability and the use of functions as first-class citizens. Functional programming can help to make code more modular, testable, and maintainable. AI and machine learning. JavaScript is increasingly being used for artificial intelligence and machine learning applications, with libraries like TensorFlow.js and Brain.js providing powerful tools for building AI and ML models in the browser. This opens up new possibilities for making intelligent and interactive web applications. Server-side JavaScript. JavaScript is not just limited to the client side of web development, but it can also be used for server-side programming with the help of platforms like Node.js. This allows developers to write both client-side and server-side code using the same language and enables them to build fast, scalable, and high-performance web applications. Progressive web apps. Progressive web apps, PWAs, are web applications that can provide a native app-like experience on mobile devices. They can be installed on a user's home screen and can work offline, providing a seamless and responsive user experience. JavaScript plays a key role in developing PWAs, as it allows developers to make dynamic and interactive user interfaces and implement features like push notifications and background syncing. Accessibility. Accessibility is an important consideration in web development, and JavaScript can play a key role in making accessible web applications. Techniques like ARIA attributes and keyboard navigation can be used to ensure that web applications are accessible to users with disabilities. Web components. Web components are a set of web platform APIs that allow developers to make reusable UI components that can be used across different web applications. JavaScript is a key part of web components, as it allows developers to define custom elements, make shadow DOM, and use the HTML template element. Community. JavaScript has a thriving and active community of developers, with a wide range of resources, tutorials, and tools available. This community is constantly pushing the boundaries of what is possible with JavaScript, and new innovations and techniques are being developed all the time. Security. JavaScript can also play a role in ensuring the security of web applications. For example, it can be used to validate user input and prevent against common web vulnerabilities like cross-site scripting, XSS, and cross-site request forgery, CSRF. Browser compatibility. JavaScript can sometimes behave differently in different web browsers, which can cause compatibility issues for web developers. However, many tools and techniques are available to help ensure that JavaScript code works correctly across different browsers, including polyfills and feature detection. Optimization. JavaScript performance can be critical for ensuring that web applications run smoothly and efficiently. Techniques like code minification, caching, and lazy loading can help to optimize JavaScript code and reduce load times. Dynamic user interfaces. JavaScript can be used to make dynamic and interactive user interfaces, enabling users to interact with web applications in new and interesting ways. Techniques like Ajax and single-page applications allow for fast and responsive UIs that can update in real time without requiring a full-page reload. Versatility. JavaScript's versatility is one of its greatest strengths. It can be used for a wide range of applications, from simple animations and interactive elements on a web page to complex and sophisticated web applications, mobile apps, and even desktop applications. As a result, JavaScript remains one of the most popular and widely used programming languages in the world. This is a conversation between 1-Minute Coder and ChatGPT about object-oriented programming. 1-Minute Coder. Hi, ChatGPT. I'm interested in learning more about object-oriented programming. Can you explain it to me? Absolutely, 1-Minute Coder. Object-oriented programming, or OOP, is a programming paradigm that revolves around objects, which are instances of classes. It's a way of organizing code into reusable and modular structures. 1-Minute Coder. That sounds interesting. Can you tell me more about classes and objects? Certainly. A class is like a blueprint or a template for an object. It defines the attributes and methods that an object of that class will have. An object, on the other hand, is an instance of a class. It's an actual entity that can be generated, manipulated, and destroyed during program execution. 1-Minute Coder. I see. Can you give me an example of a class and an object? Sure. Let's say we have a class called car. This class could have attributes like make, model, and year, as well as methods like start engine and stop engine. An object of this class could be a specific car, such as a 2019 Honda Civic. 1-Minute Coder. Got it. So, what are some benefits of using OOP? There are many benefits to using OOP. One is that it allows for code reuse, which means that you can make classes and objects that can be used in multiple parts of a program. Another benefit is that it can make code easier to read and understand, since it allows you to organize code into logical structures. Additionally, OOP can make it easier to maintain and update code over time, since changes can be made to specific classes and objects without affecting the rest of the program. 1-Minute Coder. That all makes sense. Thank you for explaining OOP to me, ChatGPT. You're welcome, 1-Minute Coder. Let me know if you have any more questions. 1-Minute Coder. Yes, actually I have one more question. What are some common OOP concepts? Great question, 1-Minute Coder. Some common OOP concepts include encapsulation, inheritance, and polymorphism. Encapsulation refers to the practice of hiding the internal details of a class or object from the outside world, and only exposing a public interface. Inheritance allows for the creation of new classes that are based on existing classes, inheriting their attributes and methods. Polymorphism allows objects of different classes to be treated as if they were of the same class, which can be useful for creating more flexible and extensible code. 1-Minute Coder. Wow, those all sound like really useful concepts. Do you have any recommendations for learning more about OOP? Absolutely. There are many great resources out there for learning about OOP. Some popular ones include books, online courses, and tutorial websites like W3 Schools or Codecademy. It's also a good idea to practice writing your own OOP code and experimenting with different concepts to get a better understanding of how they work. 1 Minute Coder. Thanks for the recommendations, ChatGPT. I'm excited to dive deeper into OOP now. You're welcome, 1 Minute Coder. Good luck with your OOP learning journey, and let me know if you have any more questions. 1 Minute Coder. Thank you, ChatGPT. Are there any downsides to using OOP? While OOP can be a powerful and flexible programming paradigm, it's not always the best choice for every situation. One downside to OOP is that it can add complexity and overhead to a program, since it involves creating and managing multiple objects and classes. Additionally, it can be more difficult to debug and troubleshoot OOP code, especially if there are many layers of inheritance and polymorphism involved. Finally, some developers argue that OOP can lead to a bloated codebase with unnecessary abstraction layers and other overhead, which can make it harder to maintain and update over time. 1 Minute Coder. I see. So, when should I consider using OOP in my own programs? It really depends on the specific requirements and constraints of your program. If you need to make complex, reusable objects with multiple attributes and methods, or if you want to organize your code into logical, modular structures, then OOP may be a good choice. However, if your program is simple and straightforward, or if you're working within a specific framework or programming language that doesn't support OOP well, then it may not be worth the extra complexity. 1 Minute Coder. That makes sense. Thanks for your help, ChatGPT. You're welcome, 1 Minute Coder. I'm always here to assist you with your programming questions. 1 Minute Coder. Thank you, ChatGPT. Are there any popular programming languages that heavily use OOP concepts? Yes, there are several popular programming languages that make heavy use of OOP concepts. Some examples include Java, Python, C++, and Ruby. These languages all have built-in support for classes, objects, inheritance, and polymorphism, making it easy to write OOP code. Additionally, many popular software development frameworks and libraries, such as Django for Python and Ruby on Rails for Ruby, are designed around OOP principles. 1 Minute Coder. That's good to know. Thanks again for your help, ChatGPT. You're welcome, 1 Minute Coder. Don't hesitate to ask if you have any more questions about OOP or programming in general. 1 Minute Coder. Actually, I do have one more question. Can you give me an example of a real-world application of OOP? Sure, 1 Minute Coder. OOP is used in a wide variety of real-world applications, from video games to financial systems to web applications. One example of an application that heavily uses OOP is a 3D modeling and animation software like Autodesk Maya. In Maya, users can make complex, reusable objects such as models, textures, and lighting setups, which can be organized into a hierarchical structure of scenes and layers. The software also supports inheritance and polymorphism, allowing users to make new objects based on existing ones and to manipulate objects in flexible and extensible ways. 1 Minute Coder. Wow, that's really interesting. I had no idea that OOP was used in 3D modeling software. Yes, OOP is a versatile and powerful programming paradigm that can be used in many different applications. It's definitely worth learning more about if you're interested in software development. 1 Minute Coder. Thanks again for all your help, ChatGPT. I'm definitely interested in learning more about OOP now. You're welcome, 1 Minute Coder. I'm glad I could help. Good luck with your programming journey, and feel free to ask me any questions you have in the future. This is a conversation between 1 Minute Coder and ChatGPT about classes in programming. Hi ChatGPT, I'm interested in learning more about classes in programming. Can you explain what they are? Of course, 1 Minute Coder. In programming, a class is a blueprint or template for making objects that share similar characteristics and behavior. Interesting. Can you give me an example of a class? Sure thing. Let's say we have a class called Person. This class might have attributes such as name, age, and gender, and methods such as walk and talk. We can make multiple objects of this class, each with their own specific values for the attributes. I see. So why are classes important in programming? Classes are important because they allow us to organize and structure our code in a logical and efficient way. By defining classes, we can group related data and behavior together, making our code easier to read and maintain. Additionally, classes support encapsulation, which means that the internal workings of a class can be hidden from other parts of the program, reducing the risk of unintended interference or bugs. That makes sense. Are there different types of classes in programming? Yes, there are several different types of classes, such as abstract classes, interface classes, and derived classes. Each type serves a specific purpose and has its own set of rules and characteristics. I see. Is there a difference between a class and an object? Yes, there is a difference between a class and an object. A class is a blueprint or template for making objects, whereas an object is an instance of a class with its own unique set of values for the attributes defined in the class. Think of it this way, a class is like a recipe for making cookies. It defines the ingredients, instructions, and overall structure for making cookies. An object, on the other hand, is a specific batch of cookies that you actually bake using the recipe. Each batch of cookies is unique and has its own set of characteristics, but they all follow the same recipe. That's a helpful analogy. Can you tell me more about attributes and methods in a class? Sure. Attributes are variables that are defined within a class and hold specific values for an object of that class. Methods, on the other hand, are functions that are defined within a class and perform specific actions or operations on the object of that class. For example, in a person class, the name, age, and gender attributes might hold specific values for an object of that class, while the walk and talk methods might perform specific actions on the object, such as making the person walk or talk. Do we call the variables in a class as properties? And do we call the functions inside a class as methods? Yes, you're correct. In object-oriented programming, we generally refer to the variables within a class as properties or attributes, and the functions within a class as methods. Can you explain the concept of inheritance in classes? Sure thing, 1 minute coder. Inheritance is a concept in object-oriented programming where you can make a new class based on an existing class. The new class, called a derived class or subclass, inherits the attributes and methods of the existing class, called the base class or superclass, and can also add new attributes and methods or modify existing ones. For example, let's say we have a vehicle class with attributes such as make, model, and year. We can then make a car class and a truck class that inherit the attributes of the vehicle class, but also have their own unique attributes such as number of doors for the car and cargo capacity for the truck. That's really useful. How does encapsulation work in classes? Encapsulation is the concept of hiding the internal workings of a class from other parts of the program, while still allowing access to the class's attributes and methods through a public interface. For example, in a person class, we might have an attribute called age that we don't want other parts of the program to be able to change directly. We can achieve this by making the age attribute private and only allowing access to it through a public method, such as a getAge method. That makes sense. Thanks for explaining, ChatGPT. You're welcome, 1 minute coder. I'm glad I could help. Thanks ChatGPT. I also want to add some things. JavaScript classes are templates for generating objects. Classes act as the blueprint or a template or a prototype for us to generate objects. Let's say we are going to make a program that shows the information of all the players in the Turkish Super League. Each player should have a name, number of goals, age, match played. There should be a lot of features. We cannot write these features haphazardly, randomly, for each individual player. We need to make a sketch template draft prototype blueprint. In this sketch, we should write down all the characteristics that a player should have. We do this job using a class. And each player we generate using this class is an object. Serdar object, Arda object, Emre object. If we store these objects in an array, we can use array methods. We can make a filter or find those who score more than 5 goals. We can sort by goals scored. Each player has goals feature. Because each of them is generated using the template, the class, and there is a property called goals in this template, the class. How would we do this if we didn't use a template, the class? Or we can find the top scorer. We can find the 11 most expensive players. If we pull data from an API in JSON format, it is presented to us in a similar way to the above. We can also use it in the same way. Before presenting this API to the outside, they made templates with classes and generated objects using these classes. They did similar work before releasing the data. We get this data presented to us as a string from the API, the data is transmitted as a string, and we convert it back to the above formats by typing json.parse. The data we will use will be similar to what we described above. And we can repeat the same operations that we applied above. Find, filter, sort. You can use array methods on it.
This is a conversation between 1-Minute Coder and ChatGPT about clean coding. Hello ChatGPT. What exactly is clean coding?
Hello 1-Minute Coder. Clean coding refers to the practice of writing code that is easy to understand, maintain, and modify. It involves using clear and descriptive names for variables, functions, and classes, organizing code into logical modules, and minimizing complexity and duplication.
Why is it important to write clean code?
There are several reasons why writing clean code is important. First, it makes it easier for other developers to understand and modify your code, which can save time and reduce errors. Second, it makes it easier for you to maintain and update your own code in the future. Finally, writing clean code can improve the performance and reliability of your software.
That all makes sense. What are some tips for writing clean code?
There are many tips for writing clean code, but here are a few key ones. Use clear and descriptive names for variables, functions, and classes. Keep functions and classes small and focused on a single task. Avoid duplicating code or logic. Use comments sparingly and only when necessary. Format your code consistently and in a readable way. Keep your code organized into logical modules. Test your code thoroughly to ensure it works as intended.
Those are great tips. Thanks for sharing. Sometimes when I'm coding, I get so focused on getting the job done quickly that I forget to focus on writing clean code. Do you have any advice on how I can train myself to write clean code consistently?
That's a common challenge, but there are some things you can do to help yourself write cleaner code. For example, you can set aside time each day to review and refactor your code, with a focus on making it more readable and maintainable. You can also practice writing clean code by working on small projects or exercises that emphasize code clarity and organization. Another helpful approach is to pair program with someone who is skilled at writing clean code, so you can observe their methods and learn from them.
I've heard that there are some principles of clean coding that developers should follow. Can you tell me more about that?
Yes, there are several principles of clean coding that can help guide developers in writing better code. One of the most well-known is the SOLID principles, which stands for single responsibility, open-closed, list-off substitution, interface segregation, and dependency inversion. These principles emphasize writing code that is modular, extensible, and easy to maintain. Another principle of clean coding is the DRY principle, which stands for don't repeat yourself. This principle emphasizes avoiding code duplication and instead writing reusable code that can be used in multiple places. Additionally, there's the KISS principle, which stands for keep it simple, stupid. This principle emphasizes the importance of writing code that is easy to understand and maintain, rather than code that is overly complex or clever.
Is there another interpretation of the KISS principle?
The KISS principle is commonly understood to stand for keep it simple, stupid, or keep it short and simple.
Keep it short and simple is better. No need to use a stupid word. Those all sound like great principles to follow. Are there any other principles of clean coding that I should be aware of?
Yes, there are many other principles and best practices for writing clean code, such as using descriptive variable and function names, formatting code consistently, avoiding global variables, and minimizing side effects. The key is to prioritize readability, maintainability, and simplicity when writing code, and to continuously look for ways to improve and refactor your code as you go.
Can you tell me more about Solid?
Sure, I can explain the Solid principles in more detail. The Solid principles were introduced by Robert C. Martin in his book Agile Software Development Principles, Patterns, and Practices, and they are a set of guidelines for writing maintainable and extensible code. The Solid acronym stands for S. Single Responsibility Principle. This principle states that a class should have only one reason to change, meaning that each class should have a single responsibility or purpose. By keeping classes focused on a single responsibility, they become more maintainable and easier to modify without affecting other parts of the codebase. O. Open-closed principle. This principle states that software entities should be opened for extension but closed for modification. This means that you should design your code to allow for future changes and extensions without having to modify the existing code. This can be achieved through the use of abstraction and interfaces. L. Liskov substitution principle. This principle states that objects of a superclass should be able to be replaced with objects of a subclass without affecting the correctness of the program. In other words, subclasses should be able to be used in place of their parent classes without causing any issues. I. Interface segregation principle. This principle states that clients should not be forced to depend on interfaces they do not use. This means that you should design interfaces that are specific to their intended use cases, rather than making one large interface that covers everything. D. Dependency inversion principle. This principle states that high-level modules should not depend on low-level modules, but both should depend on abstractions. This means that you should depend on abstractions rather than concrete implementations, which makes your code more flexible and easier to modify. By following the Solid principles, you can make code that is more modular, testable, and maintainable, and that can be easily extended as your software evolves over time.
Can you tell me more about Dry?
The DRY principle stands for Don't Repeat Yourself, and it is a best practice for writing clean and maintainable code. At its core, the DRY principle states that you should avoid duplicating code whenever possible. Instead, you should strive to write reusable code that can be shared across different parts of your application. There are several benefits to following the DRY principle. First and foremost, it can help make your code more maintainable. When you have multiple instances of the same code scattered throughout your application, it can be difficult to make changes or fix bugs without accidentally introducing new issues. By consolidating your code into reusable functions or modules, you can reduce the risk of introducing errors and make it easier to keep your code up to date. In addition to improving maintainability, following the DRY principle can also make your code more efficient. When you have multiple instances of the same code, you may be duplicating work unnecessarily. By consolidating that code, you can reduce the amount of redundant work that your application has to perform. Overall, the DRY principle is a powerful tool for improving the quality of your code. By striving to avoid duplication and write reusable code, you can make applications that are more maintainable, efficient, and easy to work with.
Keep it short and simple is better. No need to use a stupid word. What does best practice mean?
In software development, best practices refers to a set of guidelines or recommendations that have been established through experience, research, and analysis. These guidelines are generally considered to be the most effective and efficient ways to achieve a particular goal or solve a particular problem. Best practices can cover a wide range of topics, from coding standards and design patterns to project management and team communication. They are based on the collective knowledge and experience of the software development community and are continually evolving as new tools and technologies emerge. Following best practices can help you write better code, reduce errors, and increase the efficiency and effectiveness of your development process. They can also help you avoid common pitfalls and ensure that your software meets industry standards and regulations. However, it's important to note that best practices are not absolute rules that must be followed in every situation. There may be cases where deviating from a best practice is the best course of action, depending on the specifics of your project and your team's needs.
Can you tell me about a bad code and a good code?
Sure. The difference between good and bad code can be quite significant, and it can have a big impact on the quality, maintainability, and efficiency of your software. Bad code is often characterized by a number of common issues, such as poor naming conventions, variables, functions, and classes that are poorly named can make it difficult to understand what the code is doing, leading to confusion and errors. Long functions or classes, code that is too long can be hard to follow and understand, making it harder to maintain or modify in the future. Inconsistent formatting, code that is not formatted consistently can be hard to read and can make it more difficult to identify and fix errors. Code duplication, code that is duplicated across multiple parts of your application can be hard to maintain, as any changes or updates must be made in multiple places. Lack of comments or documentation, code that is poorly documented can be hard to understand, especially for new team members or those unfamiliar with the codebase. On the other hand, good code is often characterized by the following qualities. Good naming conventions, variables, functions, and classes that are named in a clear and descriptive way can make it easy to understand what the code is doing. Short and focused functions or classes, code that is organized into smaller, focused functions or classes can be easier to understand and maintain. Consistent formatting, code that is formatted consistently can be easier to read and can make it easier to identify and fix errors. Reusability, code that is written to be reusable can help reduce duplication and make it easier to maintain and modify. Well-documented, code that is well documented with clear comments and documentation can be easier to understand and maintain. In summary, good code is characterized by clear naming conventions, concise and focused code, consistent formatting, reusability, and clear documentation. Conversely, bad code is characterized by poor naming conventions, long and convoluted code, inconsistent formatting, code duplication, and poor documentation.
Should we write comments to write good code, or is good code self-explanatory?
While it's true that good code should ideally be self-explanatory, in practice, writing comments can still be very beneficial. Good comments can provide additional context or explanation that may not be immediately apparent from the code itself. They can help other developers understand why certain design decisions were made, or provide additional information on how the code works. Comments can also be especially helpful in complex or large code bases, where it can be difficult to understand how different pieces of code fit together. That being said, it's important to use comments judiciously. Comments should be clear, concise, and focused on explaining why something is being done, rather than what is being done. Comments that simply repeat what the code is doing can be redundant and clutter up the code base. In addition, it's important to keep in mind that comments are not a substitute for clear, well-structured code. If your code is poorly structured or hard to understand, adding comments may help in the short term, but in the long run, refactoring your code to make it more clear and concise is the better solution. In summary, while good code should ideally be self-explanatory, writing comments can still be beneficial in providing additional context and explanation, particularly in large or complex code bases. However, comments should be used judiciously and should not be relied upon as a substitute for clear, well-structured code.
There's a sentence like good code documents itself.
Yes, The saying "good code documents itself" is a common sentiment among developers, and it is based on the idea that well-written code should be clear, concise, and self-explanatory. In other words, good code should be easy to read and understand without the need for extensive comments or documentation. This is achieved through a combination of clear naming conventions, concise and focused code, consistent formatting, reusability, and clear documentation, as I mentioned earlier. However, it's important to note that this doesn't mean that comments or documentation are not necessary. As I mentioned earlier, comments can provide additional context or explanation that may not be immediately apparent from the code itself, and can be especially helpful in complex or large code bases. Documentation, in turn, can provide a higher-level overview of how different parts of the code fit together and can help ensure that the code meets any relevant standards or regulations. So while good code documents itself is a useful guiding principle, it's important to remember that comments and documentation are still important tools for ensuring that your code is well understood and well maintained over time.
You said reusable code is good code.
Yes, reusable code is generally considered to be a hallmark of good code, as it can help reduce duplication and make your code base more modular and maintainable. Reusable code refers to code that can be easily used in different parts of your application or even in other applications entirely. This can be achieved through techniques such as making functions or classes that perform specific, well-defined tasks, using design patterns, or using libraries or frameworks. By making reusable code, you can reduce the amount of duplicated code in your application, which can in turn make it easier to maintain and modify. Reusable code also encourages a more modular approach to programming, where each component of your application is focused on a specific task, rather than being tightly coupled with other parts of the code. In addition, making reusable code can help improve code quality, as you are forced to think more carefully about how your code is designed and structured. This can lead to more concise, focused code that is easier to understand and maintain over time.
What do you mean with the modular approach to program?
A modular approach to programming refers to the practice of breaking up a program into smaller, more manageable pieces, or modules, each of which is responsible for a specific task or set of tasks. In a modular approach, each module is designed to be relatively independent of the others, with well-defined inputs and outputs, making it easier to test and modify. By dividing the program into smaller modules, it becomes easier to reason about the program's behavior and make changes without affecting the entire code base. A modular approach can make code more maintainable and scalable, as it allows you to add new functionality to your application by simply adding new modules rather than modifying existing code. It also makes it easier to reuse code, as individual modules can be used in different parts of your application or even in other applications entirely. Modularity can be achieved through a variety of techniques, including object-oriented programming, where each object represents a module, or functional programming, where each function represents a module. The use of design patterns and architectural patterns can also help enforce modularity. In summary, a modular approach to programming involves breaking up a program into smaller, well-defined modules, each of which is responsible for a specific task. This approach can make code more maintainable, scalable, and reusable, and can be achieved through a variety of techniques and design patterns.
Clean code always looks like it was written by someone who cares. What did clean code author R.C. Martin mean by this sentence?
When Robert C. Martin, the author of Clean Code, said that clean code always looks like it was written by someone who cares, he meant that writing clean, well-organized code requires a certain level of attention to detail and consideration for other developers who may work on the code in the future. Essentially, writing clean code requires caring about the quality of your code and its impact on others. It means taking the time to write clear, concise code, using meaningful names for variables and functions, organizing the code in a logical manner, and adhering to best practices and design principles. When code is well organized and follows these principles, it is more readable and easier to maintain, making it more valuable for the development team and future developers who may need to work with the code. By writing clean code, you are showing that you care about the quality of your work and are committed to making it as accessible and easy to use as possible. In summary, when R.C. Martin said that clean code always looks like it was written by someone who cares, he meant that writing clean code requires attention to detail, consideration for others, and a commitment to producing high-quality, maintainable code.
Of course, bad code can be cleaned up. But it's very expensive. What did clean code author R.C. Martin mean by this sentence?
When Robert C. Martin, the author of Clean Code, said that, of course, bad code can be cleaned up, but it's very expensive, he meant that it is possible to improve poorly written code, but doing so can be time-consuming and costly. In many cases, poorly written code can be difficult to understand and maintain, which can slow down the development process and make it more challenging to add new features or fix bugs. To address these issues, developers may need to invest a significant amount of time and effort into refactoring the codebase, which involves restructuring and optimizing the existing code without changing its external behavior. While refactoring can be an effective way to improve the quality of a codebase, it can be a time-consuming process that requires a deep understanding of the code structure and dependencies. In addition, refactoring can introduce new bugs or issues if not done carefully, so it requires careful planning and execution. In contrast, writing clean code from the outset can help avoid these issues and reduce the need for extensive refactoring down the line. By adhering to best practices and design principles, developers can produce code that is easier to understand, modify, and maintain, reducing the likelihood of errors and reducing the amount of time and effort required to make changes in the future. In summary, when R.C. Martin said that, of course, bad code can be cleaned up, but it's very expensive, he meant that while it is possible to improve poorly written code through refactoring, doing so can be time-consuming, costly, and potentially risky. Writing clean code from the outset can help avoid these issues and make the development process more efficient and effective.
Don't use a comment when you can use a function or a variable. What did clean code author R.C. Martin mean by this sentence?
When Robert C. Martin, the author of Clean Code, said don't use a comment when you can use a function or a variable, he meant that it is often better to use well-named functions or variables instead of adding comments to explain what code is doing. This can improve the readability and maintainability of the code.
When you see commented out code, delete it.
When you see commented out code, delete it. This is a principle advocated by many software development experts, including Robert C. Martin, the author of Clean Code. The reason for this is that commented out code can clutter the code base and make it more difficult to read and understand. Commented out code is often the result of developers trying to temporarily remove code without actually deleting it, in case they need it again in the future. However, this approach can lead to confusion, as it can be unclear whether the commented out code is still relevant or should be deleted. Instead of commenting out code, developers should use version control systems like Git to keep track of changes to the codebase. This makes it easy to roll back changes if necessary without cluttering the code with unnecessary comments. In summary, the principle of when you see commented out code, delete it means that developers should avoid using commented out code and instead use version control systems to manage changes to the codebase. This can improve the readability and maintainability of the code, making it easier to understand and modify over time.
Honesty in small things is not a small thing.
The phrase honesty in small things is not a small thing means that even small acts of honesty are important and have a significant impact on the overall integrity of a person or system. In the context of software development, this means that it is important for developers to prioritize honesty and integrity in all aspects of their work, including small details like variable naming and code formatting. When developers are honest in even small details, it can help build trust with their colleagues and stakeholders and contribute to a culture of honesty and transparency. Furthermore, small acts of dishonesty can also have a negative impact on the quality and reliability of software. For example, if a developer cuts corners or takes shortcuts in their code, it may introduce bugs or security vulnerabilities that can have serious consequences down the line. In summary, honesty in small things is not a small thing emphasizes the importance of prioritizing honesty and integrity in all aspects of software development, even small details. By doing so, developers can build trust, promote transparency, and contribute to the overall quality and reliability of the software they make.
The first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that.
The first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that comes from Robert C. Martin's book Clean Code. The idea behind this quote is that functions should be as small as possible. Small functions are easier to understand, test, and maintain than large, complex functions. Small functions also tend to be more reusable and easier to refactor. When functions are too large, they become difficult to understand and can be hard to test. Large functions also tend to have more dependencies and can be harder to refactor, which can lead to code duplication and other issues. By keeping functions small, developers can make code that is more modular, easier to understand, and more flexible. This can make the code easier to maintain and can help to reduce bugs and other issues over time. In summary, the first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that emphasizes the importance of making small, well-organized functions in software development.
Duplication is the primary enemy of a well-designed system. It represents additional work, additional risk, and additional unnecessary complexity.
Duplication is the primary enemy of a well-designed system. It represents additional work, additional risk, and additional unnecessary complexity highlights the negative impact of code duplication on software development. Code duplication occurs when similar or identical code is repeated multiple times throughout a system. This can lead to additional work because changes made to one instance of the code may need to be replicated in other instances. It also increases the risk of errors, as changes may be missed or inconsistent across different parts of the system. In addition, code duplication can lead to unnecessary complexity in a system, making it harder to understand, test, and maintain. This can lead to higher maintenance costs and increased technical debt over time. By avoiding code duplication, developers can make systems that are easier to understand, test, and maintain. This can help to reduce the risk of errors and can make it easier to add new features and functionality over time. In summary, duplication is the primary enemy of a well-designed system. It represents additional work, additional risk, and additional unnecessary complexity emphasizes the importance of avoiding code duplication in software development.
A long descriptive name is better than a long descriptive comment.
A long descriptive name is better than a long descriptive comment highlights the importance of using clear and descriptive names in software development. This can make code easier to understand and maintain, and can reduce the need for long and complex comments that can be difficult to keep up to date over time.
Error handling is important, but if it obscures logic, it's wrong.
Error handling is important, but if it obscures logic, it's wrong emphasizes the importance of error handling in software development, while also highlighting the need to balance error handling with the overall logic of the system. Error handling is an important aspect of software development, as it allows programs to respond to unexpected situations and handle errors gracefully. However, if error handling is implemented in a way that makes the code more complex or difficult to understand, it can be counterproductive and even harmful to the overall logic of the system. In order to balance error handling with logic, developers should strive to make error handling mechanisms that are simple, clear, and consistent with the overall design of the system. This can involve using standard error handling patterns, providing informative error messages, and avoiding complex error handling logic that can obscure the underlying logic of the system. In summary, the quote error handling is important, but if it obscures logic, its wrong underscores the importance of effective error handling in software development, while also emphasizing the need to balance error handling with the overall logic and design of the system.
Indeed, the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as part of the effort to write new code. Therefore, making it easy to read makes it easier to write.
The quote indeed, the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as part of the effort to write new code. Therefore, making it easy to read makes it easier to write highlights the fact that developers spend much more time reading existing code than writing new code, and emphasizes the importance of writing code that is easy to read and understand. This idea recognizes that writing clean, readable, and maintainable code is not just important for its own sake, but can also have a significant impact on the efficiency and productivity of the development process. By making code easy to read and understand, developers can more quickly and easily understand the behavior of the system, make changes and improvements, and avoid errors and bugs. In order to achieve this goal, developers should strive to write code that is well organized, uses meaningful names for variables and functions, avoids unnecessary complexity and duplication, and adheres to established coding standards and best practices. In summary, the quote indeed, the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as part of the effort to write new code. Therefore, making it easy to read makes it easier to write highlights the importance of writing clean and readable code, and underscores the idea that doing so can have a significant impact on the efficiency and productivity of the development process.
It is not enough for code to work.
The statement "it is not enough for code to work" emphasizes that the quality of code is not solely determined by its ability to produce correct results. While correctness is certainly important, code that is difficult to read, understand, or maintain can be a liability to a development team, regardless of whether it produces the desired results. In addition to correctness, high-quality code should also be easy to read, understand, and modify. It should follow established coding standards and best practices, and should be organized in a logical and intuitive manner. By adhering to these principles, developers can ensure that their code is not only correct, but also maintainable, scalable, and adaptable to changing requirements and environments. Furthermore, code that is easy to read and understand can also be more easily tested, debugged, and extended. This can result in fewer bugs and errors, faster development cycles, and improved overall productivity. In summary, the statement "it is not enough for code to work" emphasizes the importance of not only correctness, but also readability, maintainability, and adherence to established standards and best practices in producing high-quality code that is effective, efficient, and adaptable.
A long descriptive name is better than a short enigmatic name. A long descriptive name is better than a long descriptive comment.
This statement emphasizes the importance of using descriptive and meaningful names for variables, functions, and other elements in code. Long, descriptive names can make it easier for other developers to understand the purpose and function of a particular piece of code without needing to read through lengthy comments. This can help to improve code readability, maintainability, and overall quality.
You should name a variable using the same care with which you name a firstborn child.
This statement highlights the importance of choosing clear, meaningful, and descriptive names for variables, as well as the level of care and attention that should be given to this task. Just as parents carefully choose names for their children, developers should take the time to carefully choose names for their variables in order to make the code more readable and understandable.
Thank you very much, ChatGPT.
You're welcome, 1 Minute Coder. It was a pleasure assisting you with your questions about clean coding. This is a conversation between 1 Minute Coder and ChatGPT about JSON. Hello, 1 Minute Coder. I'd be happy to help you understand JSON. What would you like to know?
Can you explain to me what JSON is and why it's useful?
Sure. JSON stands for JavaScript Object Notation. It's a lightweight data interchange format that is easy for humans to read and write and easy for machines to parse and generate. JSON is used to transmit data between a server and a web application as an alternative to XML. JSON has become increasingly popular because it's a simple and efficient way to store and transmit data. It's also easy to use with many programming languages and frameworks, including JavaScript, Python, and Ruby. Additionally, because it's so lightweight, it's often faster than other data formats, which is especially useful when working with large data sets. One thing to keep in mind is that JSON only supports a limited set of data types, such as strings, numbers, booleans, and arrays. It doesn't support more complex data types, such as functions or objects with circular references. Also, while JSON is easy to read and write, it's important to ensure that your data is properly formatted according to the JSON specification, or it may not be parsed correctly.
Can you explain to me the difference between JSON and XML?
Certainly. XML, or Extensible Markup Language, is another data interchange format that's been around for longer than JSON. Like JSON, it's used for transmitting data between servers and web applications. However, XML is more verbose than JSON and can be more complicated to read and write. It's also less efficient in terms of file size, which can make it slower to transmit large amounts of data. Additionally, XML requires more overhead to parse than JSON, which can make it slower in some situations. On the other hand, XML is more flexible than JSON in terms of the types of data it can represent. It can represent more complex data structures and supports a wider range of data types. XML is also widely used in industries like finance and healthcare, where data accuracy and consistency are critical. So, it really depends on the specific needs of your project as to which format you would choose to use. Do you have any other questions about JSON or related topics?
Yes, I'm curious about how JSON is used in web development. Can you give me some examples?
Certainly. JSON is used extensively in web development, particularly in the context of web APIs. Web APIs, or Application Programming Interfaces, allow different software applications to communicate with each other. When a web application makes a request to a web API for data, the API will often respond with data in JSON format. The web application can then parse the JSON data and use it to update its user interface. For example, let's say you're building a weather app. Your app might make a request to a weather API for the current weather conditions in a specific location. The API would respond with data in JSON format, which your app would then parse and use to display the current weather conditions to the user. JSON can also be used to store data in web applications, such as user preferences or settings. In this case, the data would be stored in a JSON file or database, and the web application would use JavaScript or another programming language to read and write to the file or database. Do you have any more questions, or is there anything else you'd like to know about JSON and its applications in web development?
Yes, I'm curious about how to parse JSON data in JavaScript. Can you explain that to me?
Certainly. In JavaScript, you can use the built-in JSON object to parse JSON data. The JSON object has two methods, JSON.parse and JSON.stringify. The JSON.parse method is used to parse JSON data into a JavaScript object. The method returns a JavaScript object, which we can then access using dot notation. The JSON.stringify method, on the other hand, is used to convert a JavaScript object into a JSON string. The method returns a JSON string, which we can then use for transmitting or storing data.
Thank you very much. Data is passed as a string when being transmitted, right?
Yes, that's correct. When data is transmitted over the internet using JSON, it is sent as a string. This means that the data is serialized into a string format before it is transmitted, and then deserialized into its original data format on the receiving end. JSON uses a simple text format that is easy for humans to read and write, but it's also easy for computers to parse and generate. This makes it an ideal format for transmitting data over the internet. So, when you make a request to a web API that returns data in JSON format, the API will send the JSON data as a string, and then your client-side application will use the JSON.parse method in JavaScript to convert the JSON string back into a JavaScript object that can be used in your code.
This is a conversation between 1-Minute Coder and ChatGPT about asynchronous programming. Hi ChatGPT, what is synchronous coding? Synchronous coding is a programming style in which each statement of code is executed one at a time in sequence. Each statement must be completed before the next one can begin, which means that the program will wait for one statement to finish before moving on to the next one. In synchronous code, if any statement takes a long time to complete, the program will be blocked and will not be able to do anything else until that statement finishes executing. This can make the program less responsive and may result in poor user experience. Synchronous code is easy to read and understand, as the sequence of operations is clear and straightforward. However, it can be limiting in certain situations, such as when working with time-consuming operations like fetching data from a remote server or processing large amounts of data. In contrast, asynchronous coding allows for non-blocking operations and enables programs to continue running while waiting for long-running tasks to complete. By using asynchronous coding, you can improve the performance and responsiveness of your program. I'm trying to wrap my head around asynchronous programming. Can you explain it to me? Of course, 1-Minute Coder. Asynchronous programming is a programming paradigm that allows programs to run efficiently by executing multiple tasks concurrently. In traditional programming, a program executes tasks sequentially, one after another. In contrast, asynchronous programming allows tasks to execute concurrently, which can lead to significant improvements in program performance. Asynchronous programming is particularly useful in situations where programs need to perform tasks that can take a long time to complete, such as network communication, file I/O, input-output, or database queries. By executing these tasks asynchronously, programs can continue to execute other tasks while waiting for the longer-running tasks to complete. Can you give me a real-life example of asynchronous programming? Sure, here's a real-life example of asynchronous programming. Suppose you're a chef and you need to prepare a meal with several dishes that have different cooking times. Rather than waiting for each dish to cook before starting the next one, you can use asynchronous programming to work on multiple dishes at the same time. For example, you might start by preparing a sauce that needs to simmer for 30 minutes. While the sauce is simmering, you can start preparing the main course, which might take 45 minutes to cook. In the meantime, you can also start chopping vegetables for a side dish that only takes 10 minutes to cook. By working on multiple dishes at once, you can finish the entire meal more quickly than if you worked on each dish sequentially. This is similar to how asynchronous programming works, where multiple tasks are executed concurrently rather than sequentially. In this example, the sauce is like a long-running task that takes time to complete, while the main course and side dish are shorter tasks that can be completed more quickly. By using asynchronous programming, you can make the most efficient use of your time and complete the entire meal more quickly. This was a good example. Can you give another example? Sure, here's another example of asynchronous programming. Suppose you're a video editor and you need to process a large number of video files that need to be compressed, converted to a different format, and have various other effects applied to them. These tasks can take a long time to complete, especially for large files, so you don't want to wait for each file to be processed before moving on to the next one. Using asynchronous programming, you can process multiple video files at the same time, without waiting for each file to be processed before starting the next one. For example, you might start processing several files in parallel, using separate threads or processes to handle each file. This allows you to make the most efficient use of your computer's resources and complete the entire batch of videos more quickly. In this example, each video file is like a task that needs to be completed, and asynchronous programming allows you to work on multiple tasks concurrently, rather than sequentially. By using parallel processing and concurrency, you can significantly reduce the time it takes to process the entire batch of videos, making your workflow more efficient and productive. When should I use asynchronous code? You should use asynchronous code in situations where you need to perform time-consuming or blocking operations, such as fetching data from a remote server or reading and writing to a file. Asynchronous code allows your program to continue running while it waits for these operations to complete, which can make your code more efficient and responsive. Asynchronous code is especially useful in web development, where network requests and user interactions can cause delays that can slow down the user experience. By using asynchronous code, you can keep the UI responsive while waiting for data to be fetched or processed in the background. In general, you should use asynchronous code whenever you need to perform operations that may take some time to complete, and you want to avoid blocking the main thread of your program. However, it's important to note that asynchronous code can also make your code more complex and harder to debug, so you should weigh the benefits and drawbacks carefully when deciding whether to use it. Continue, please. One way to implement asynchronous programming is through the use of callbacks. Callbacks are functions that are passed as arguments to other functions, and are executed when the other function has completed its task. In the case of asynchronous programming, the callback function is executed when the long-running task has completed. Another approach to asynchronous programming is through the use of promises. Promises are objects that represent the eventual completion, or failure, of a task, and allow programs to execute other tasks while waiting for the task to complete. Promises provide a more flexible and powerful approach to asynchronous programming than callbacks, and are widely used in modern programming languages. Asynchronous programming can also be implemented using the async await syntax, which was introduced in 2017. This syntax allows programs to write asynchronous code that looks like synchronous code, making it easier to read and understand. Hey ChatGPT. Because it is not clear when an asynchronous operation will end, we use callback or promise or async await. Am I right? Yes. Yes, you are correct. Asynchronous operations are non-blocking, which means that the program continues to execute while the operation is being executed in the background. To handle the result of an asynchronous operation, you can use callbacks, promises, or async await. Callbacks are functions that are passed as arguments to another function and are called once the asynchronous operation is completed. Callbacks have been a popular way to handle asynchronous operations in JavaScript for a long time. However, the problem with callbacks is that they can quickly become complicated and hard to read when dealing with complex asynchronous operations. Promises provide an alternative to callbacks that make asynchronous code more readable and easier to maintain. Promises allow you to chain multiple asynchronous operations together and handle errors more effectively. With promises, you can also use the catch method to handle errors that occurred during the execution of an asynchronous operation. Async await is a newer feature of JavaScript that provides a more natural and synchronous way to write asynchronous code. The async await syntax makes it easy to write asynchronous code that looks like synchronous code, making it easier to read and understand. Async await uses promises under the hood and provides a way to handle errors using try-catch blocks. Hey ChatGPT. If I define a variable and set its value to 0, then write an asynchronous operation. If I make the variable 1 in this asynchronous operation, and if I write this variable to the screen outside of the asynchronous operation, 0 is shown on the display, 1 is not. Yes, 1 minute coder, you are correct. In JavaScript, when you define a variable and set its value to 0, then write an asynchronous operation that changes the value of that variable to 1, and then write that variable to the screen outside of the asynchronous operation, you will see the original value of the variable, which is 0. This is because JavaScript is a single-threaded language, and the code runs in a specific order. When an asynchronous operation is started, it is pushed to a task queue and executed when the main thread is free. Meanwhile, the main thread continues to execute the remaining code. In your scenario, the asynchronous operation is still running in the background when you try to write the value of the variable to the screen outside of the asynchronous operation. So, the value of the variable is not yet updated. Once the asynchronous operation is completed, it will update the value of the variable to 1. But by that time, you have already written the original value of the variable, which is 0, to the screen. To handle this scenario, you can use callbacks, promises, or async/await to wait for the completion of the asynchronous operation before writing the value of the variable to the screen. This way, you can ensure that the value of the variable is updated before it is written to the screen. What are the benefits of asynchronous programming? There are many benefits to asynchronous programming. One of the main benefits is improved program performance, as programs can continue to execute other tasks while waiting for long-running tasks to complete. Asynchronous programming can also improve program responsiveness, as programs can continue to respond to user input while executing long-running tasks. However, asynchronous programming can also be more difficult to implement than traditional sequential programming. Asynchronous programming requires careful attention to detail, as programs must manage concurrency and synchronization issues. Additionally, asynchronous programming can make it harder to reason about program behavior, as tasks may complete in an unpredictable order. In conclusion, asynchronous programming is a powerful technique for improving program performance and responsiveness. While it can be more difficult to implement than traditional sequential programming, the benefits of asynchronous programming make it an essential technique for modern programming languages. Continue, please. Asynchronous programming is widely used in web development, where programs often need to interact with external services or APIs. Asynchronous programming can help web applications handle multiple requests concurrently, improving their performance and responsiveness. Node.js, a popular runtime environment for JavaScript, is designed specifically for asynchronous programming. Node.js uses an event-driven, non-blocking I/O, input-output, model that allows programs to handle many concurrent connections efficiently. Asynchronous programming is also widely used in other programming languages, such as Python, Java, and C#. In Python, the Asyncio library provides support for asynchronous programming, while in Java, the completable future class provides similar functionality. In conclusion, asynchronous programming is an essential technique for modern programming, particularly in situations where programs need to execute long-running tasks or interact with external services. While it can be more difficult to implement than traditional sequential programming, the benefits of asynchronous programming make it a valuable tool for improving program performance and responsiveness.
This is a conversation between 1-Minute Coder and ChatGPT about promises in JavaScript.
Why we need promises in JavaScript.
Promises are a way to handle asynchronous code in JavaScript. Asynchronous code allows your program to perform tasks without blocking other tasks from executing. However, it can be challenging to manage the flow of asynchronous code when it involves multiple tasks that depend on each other. Promises provide a solution to this challenge by providing a way to handle asynchronous operations in a more organized and streamlined way. They allow you to chain asynchronous operations together and handle errors more effectively. Here are some reasons why you might want to use promises in JavaScript. 1. Improved readability. Promises provide a cleaner and more organized way of handling asynchronous code, making your code more readable and easier to understand. 2. Error handling. Promises provide a structured way of handling errors in asynchronous code, allowing you to catch and handle errors more effectively. 3. Chaining operations. Promises allow you to chain multiple asynchronous operations together, making it easier to manage the flow of your code. 4. Avoiding callback hell. promises can help you avoid the infamous callback hell problem that can occur when dealing with complex asynchronous code. 5. Compatibility with modern JavaScript. Promises are a native feature in modern JavaScript, making them a more reliable and efficient way of handling asynchronous code than older techniques like callbacks. Overall, promises are a powerful tool for handling asynchronous code in JavaScript and can help you write more efficient, organized, and error-free code.
In short, what is a promise?
In short, a promise is an object in JavaScript that represents the eventual completion or failure of an asynchronous operation and allows you to handle its result or error. It provides a more organized and streamlined way of dealing with asynchronous code in JavaScript.
So, we use promises to manage asynchronous codes?
Yes, that's correct. Promises are used to manage asynchronous code in JavaScript. When you have an asynchronous operation in your code, like fetching data from an API or reading a file from disk, it doesn't execute immediately, and the result may not be available for some time. Promises provide a way to handle this situation by allowing you to attach handlers to the eventual completion of the operation, whether it succeeds or fails. This makes it easier to manage asynchronous code and handle errors in a more organized way.
What is asynchronous code?
Asynchronous code is code that doesn't execute in a linear fashion from top to bottom, but instead allows other code to run while it's waiting for some operation to complete. This means that the result of an asynchronous operation may not be available immediately, and your program needs to be able to handle this delay. Examples of asynchronous operations include fetching data from a server, reading and writing files, or waiting for user input. In JavaScript, asynchronous code is often managed using callbacks, promises, or async await, which provide ways to handle the delayed response of asynchronous operations and ensure that the program doesn't block while waiting for them to complete.
What is synchronous code?
Synchronous code is code that executes in a linear fashion from top to bottom, meaning that each statement is executed one at a time and must complete before the next statement can be executed. In other words, in synchronous code, the program must wait for a statement to finish executing before moving on to the next one. Examples of synchronous operations include basic arithmetic operations, variable assignments, and function calls. Because synchronous code blocks the program until each statement is complete, it can be less efficient for handling operations that take a long time to complete or depend on external resources like network requests or file I/O. Asynchronous code, on the other hand, allows the program to continue running while waiting for an operation to complete, which can improve performance and responsiveness.
Can you compare asynchronous and synchronous codes?
Sure. Here are some key differences between asynchronous and synchronous code. Execution flow. In synchronous code, each statement is executed one at a time in a linear fashion, and the program waits for each statement to complete before moving on to the next one. In asynchronous code, some operations are executed in the background while the program continues to run, allowing for more efficient handling of time-consuming operations. Blocking. Synchronous code blocks the program until each statement is complete, which can be a problem for operations that take a long time to complete or depend on external resources like network requests or file I/O. Asynchronous code, on the other hand, allows the program to continue running while waiting for an operation to complete, which can improve performance and responsiveness. Callbacks. Asynchronous code often uses callbacks to handle the results of an operation when they become available, while synchronous code doesn't need to use callbacks since the program waits for each statement to complete before moving on to the next one. Error handling. Error handling in synchronous code is often done using try-catch blocks, while asynchronous code typically uses promises or callbacks to handle errors. Readability. Synchronous code is often easier to read and understand because the execution flow is linear and straightforward, while asynchronous code can be more difficult to read and understand because the program flow may not be immediately obvious. In summary, synchronous code executes statements one at a time and blocks the program until each statement is complete, while asynchronous code allows for more efficient handling of time-consuming operations and executes some operations in the background while the program continues to run.
A promise that manages asynchronous code can be in pending state or fulfilled state or rejected state while other codes are running. Can you tell me about these states?
Yes, a promise that manages asynchronous code can be in one of three states: pending, fulfilled, or rejected. Here's a brief overview of each state. Pending. When a promise is made, it starts in a pending state. This means that the asynchronous operation it represents hasn't yet completed, and the promise is waiting for the operation to finish. Fulfilled. If the asynchronous operation is successful, the promise transitions from the pending state to the fulfilled state. In this state, the promise has a value, which can be accessed through a then method. Rejected. If the asynchronous operation encounters an error or fails, the promise transitions from the pending state to the rejected state. In this state, the promise has a reason for the rejection, which can be accessed through a catch method. Once a promise has transitioned to the fulfilled or rejected state, it cannot transition back to the pending state. Promises can be chained together using then and catch methods to manage the flow of asynchronous code and handle errors in a more organized way. It's worth noting that promises are designed to handle a single asynchronous operation. If you need to manage multiple asynchronous operations, you can use techniques like promise all or async await to manage them together.
What are then method and catch method?
Then and catch are methods that can be used to handle the outcome of a promise. The then method is used to handle a promise that has resolved successfully. It has transitioned to the fulfilled state. You can attach one or more then methods to a promise, which will be executed in the order that they are defined. The then method takes a callback function as an argument, which will receive the resolved value of the promise as its parameter. The catch method is used to handle a promise that has been rejected. It has transitioned to the rejected state. Like then method, you can attach a catch method to a promise, and it will be executed if the promise is rejected. The catch method also takes a callback function as an argument, which will receive the reason for the rejection as its parameter. Then and catch are methods that can be used to handle the outcome of a promise. The then method is used to handle a promise that has resolved successfully, while the catch method is used to handle a promise that has been rejected. You can chain then and catch methods together to handle the flow of asynchronous code and handle errors in a more organized way. When using then method, you pass a callback function as an argument that receives the resolved value of the promise. When using catch method, you pass a callback function as an argument that receives the reason for the rejection of the promise.
What is a fulfilled state?
The fulfilled state of a promise is the state when the asynchronous operation it represents has completed successfully. In this state, the promise has a value that can be accessed through a then method. Once a promise is fulfilled, it cannot transition back to the pending state.
What is rejected state?
The rejected state of a promise is the state when the asynchronous operation it represents encounters an error or fails. In this state, the promise has a reason for the rejection that can be accessed through a catch method. Once a promise is rejected, it cannot transition back to the pending state.
What is pending state?
The pending state of a promise is the initial state of a promise when it is generated. In this state, the promise is neither fulfilled nor rejected, but is instead in a state of waiting for the asynchronous operation it represents to complete. Once a promise is settled, it transitions to either the fulfilled or rejected state. It cannot transition back to the pending state.
I see. There are three states for a promise: pending, fulfilled, and rejected. The rejection reason can be accessed through a catch method. And we can access successful, fulfilled promise value through a then method.
Yes, that's correct. Once a promise settles, it transitions to either the fulfilled or rejected state. It cannot transition back to the pending state. If a promise is fulfilled, the resolved value can be accessed through a then method. If a promise is rejected, the reason for the rejection can be accessed through a catch method. Promises allow us to write more concise and readable code for managing asynchronous operations in JavaScript.
Do we use catch method to handle errors in JavaScript promises?
Yes, that's right. The catch method is used to handle errors or rejections that occur in a promise. If a promise is rejected, the catch method is called with the reason for the rejection as its argument. By handling errors with the catch method, we can gracefully handle errors and prevent them from crashing our application. Additionally, using promises with catch method allows us to write more organized and readable asynchronous code.
Is there a finally method in JavaScript promises?
Yes, there is a finally method in JavaScript promises. The finally method is a method that can be chained onto a promise after then method and catch methods to execute a block of code regardless of whether the promise resolved successfully or was rejected. The finally method is useful for running code that needs to be executed after a promise has settled, regardless of whether it was fulfilled or rejected.
Does finally method always run, whether promise succeeds or not?
Yes, that's correct. The finally method is always called, regardless of whether the promise was fulfilled or rejected. The finally method is useful for running code that needs to be executed after a promise has settled, such as closing a file or a network connection. By using the finally method, we can ensure that the code inside the finally block will always run, regardless of whether the promise was fulfilled or rejected.
What do I do if I have more than one promise in my code?
If you have multiple promises in your code, you can use the promise all method to wait for all promises to settle before continuing execution. The promise all method takes an array of promises as its argument and returns a new promise that resolves when all of the promises in the array have resolved, or rejects when any of the promises in the array have rejected.
What do you mean with returns a new promise?
When we call the promise all method with an array of promises as its argument, it returns a new promise. This new promise represents the collective state of all the promises passed to promise all. If all of the promises in the array resolve successfully, the new promise returned by promise all will also resolve successfully with an array containing the resolved values of each promise in the same order as the original array. If any of the promises in the array reject, the new promise returned by promise all will reject with the reason for the first rejection that occurred. In either case, the new promise returned by promise all allows us to handle the results of multiple promises as a single entity, making it easier to write asynchronous code.
Does it treat promise all like a single promise?
Yes, that's correct. The promise all method treats all of the promises in the array passed as its argument as a single promise. The new promise returned by promise all is resolved only when all the promises in the array have resolved. It is rejected immediately if any one of the promises in the array is rejected. Once the new promise returned by promise all is settled, either resolved or rejected, it can be handled using the standard then method and catch methods like any other promise. By treating multiple promises as a single entity, promise all allows us to write asynchronous code that is easier to reason about and easier to handle.
If one of the promises is not successful, are all of them considered unsuccessful?
Yes, that's correct. If any of the promises passed to promise all is rejected, the new promise returned by promise all is also rejected with the reason for the first rejection that occurred.
Where do I use promise all? Can you give me an example?
Sure. The promise all method is useful when you have multiple asynchronous operations that can be executed in parallel and you need to wait for all of them to complete before moving on to the next step in your code.
Give me a real-life example.
Sure. Here's a real-world example of where promise all might be used. Imagine you're building a web application that needs to display information about a user's recent activity on the site. You need to fetch data from several different endpoints to get all the information you need, such as the user's profile information, their recent posts, their friends list, and their notification history. Each of these data sources requires a separate API call, and each call takes some amount of time to complete. You could make each API call one after the other and wait for each one to complete before moving on to the next one, but that would be slow and inefficient. Instead, you can use Promise All to make all the API calls at once, then wait for all the responses to come back before processing the data and displaying it on the page. Using Promise All in this way allows you to speed up your application's load time and improve performance by fetching all the data in parallel rather than sequentially.
Well, let's say I can get information about the weather in Istanbul from many sources. I sent a request to all of them. One of them answered me. Do I have to wait for the others?
No, you don't have to wait for the other sources to respond if you have already received a response from one of them. In fact, you should stop waiting for responses from the remaining sources and process the response you have received as soon as possible to provide the user with the most up-to-date information. This is where Promise Race comes in handy. Promise Race works similarly to Promise All, but instead of waiting for all the promises to be resolved, it returns a new promise that resolves or rejects as soon as any of the input promises resolve or reject, whichever happens first. In your example, you can use Promise Race to send requests to all the weather information sources, and as soon as one of them responds with data, the Promise Race will resolve with that data, and you can process it and display it to the user. The other requests will continue running in the background, but you don't have to wait for them to finish.
Give me a real-life example for Promise Race.
Sure. Here's an example of where Promise Race might be used in a real-life scenario. Imagine you're building an e-commerce website that allows users to search for products and buy them online. One of the key features of your website is that it provides real-time stock availability information for each product. You get this information from multiple suppliers, each of which provides stock information via a different API. To ensure that your website displays the most accurate stock information to users, you want to send requests to all the suppliers simultaneously and display the results as soon as you receive a response from any of them. You can achieve this using Promise Race, which allows you to send multiple API requests at the same time and return the first response you receive, regardless of which supplier it came from. By using Promise Race in this way, you can significantly improve the performance and accuracy of your website, as you're able to display real-time stock information from the fastest supplier available, rather than waiting for all the suppliers to respond before displaying any results to the user.
So, in short, what is the difference between Promise Race and Promise All?
In short, the main difference between Promise All and Promise Race is that Promise All waits for all the input promises to resolve or reject before resolving the new promise it returns, while Promise Race returns a new promise that resolves or rejects as soon as any of the input promises resolve or reject, whichever happens first. With Promise All, you can wait for multiple asynchronous operations to complete and collect the results, which can be useful when you need to perform multiple operations in parallel and combine the results. On the other hand, Promise Race can be used when you only need the result of the fastest operation or want to implement a timeout functionality.
For example, if I need to pull the city names from an online API first, then I need to pull the weather for them. You see that the first one has to be finished before you can pull data from the second one. Because I need city names. I need to inform the online weather API for which city I want the weather.
In this scenario, you would use promise chaining. First, you would send a request to the API to get the city names. Once you receive a response with the city names, you can then use that information to make a request to the online weather API for each city. To accomplish this using promises, you would first make a promise to fetch the city names from the API. Then, you would chain a then method to that promise that would handle the response and use the city names to make requests for the weather data for each city. Finally, you would chain a catch method to handle any errors that may occur during the promise chain.
Do we use then method to chain promises?
Yes, that's correct. We use the then method to chain promises. Each time a promise resolves, we can attach a then method to it. This then method can return another promise, which allows us to chain promises together. This is commonly referred to as promise chaining. By chaining promises together, we can make a sequence of asynchronous operations that must be completed in a specific order.
What is the first thing to learn about promises?
If someone is learning JavaScript promises, the following are some important things to know. Promises are a way to manage asynchronous operations in JavaScript. They provide a way to handle the results of an asynchronous operation without blocking the main thread. A promise represents the eventual completion or failure of an asynchronous operation and can have three states: pending, fulfilled, or rejected. We use the then method to handle successful promise resolutions and the catch method to handle promise rejections. Promises can be chained together using the then method, allowing us to perform a sequence of asynchronous operations in a specific order. The Promise API also includes methods like promise.all and promise.race for handling multiple promises at once. Promises are a core concept in modern JavaScript and are used extensively in asynchronous programming with APIs, network requests, and more. Understanding promises is essential for writing modern, efficient, and scalable JavaScript code.
We have talked about all of these.
Yes, we did cover these topics during our conversation. I was summarizing the key points for someone who is just starting to learn about JavaScript promises, so they have a clear understanding of what promises are and why they are important in asynchronous programming.
When was promise added to JavaScript?
The Promise API was added to JavaScript in ES6 in 2015. It is now widely supported by modern web browsers and Node.js.
What was previously used to manage asynchronous codes?
Before the introduction of promises in JavaScript, developers used callbacks to manage asynchronous code. While callbacks are still commonly used in JavaScript, promises provide a more structured and intuitive way to handle asynchronous operations.
Were the callbacks causing the problems?
Callbacks themselves were not the problem, but managing complex asynchronous operations with callbacks could lead to issues such as callback hell or pyramid of doom, where nested callbacks become difficult to read and maintain. Additionally, callbacks are not always well suited for error handling in asynchronous code. Promises provide a cleaner and more readable syntax for managing asynchronous operations, and they also have built-in support for error handling. So, promises have become a preferred alternative to callbacks for many developers.
Thank you, ChatGPT.
Thank you, 1 Minute Coder.
Welcome to 1 Minute Coder channel. This is a conversation between 1 Minute Coder and ChatGPT about Git. What is Git? Git is a free and open-source distributed version control system that helps developers manage changes to their code over time. It was made by Linus Torvalds in 2005 and has since become one of the most popular version control systems in use. With Git, developers can track changes to their code and collaborate with others on a project. Each change is saved as a commit, which includes a message describing the changes made. This makes it easy to review changes and roll back to a previous version if necessary. Git also allows developers to work on their code offline and merge changes made by others when they come back online. This makes it easy to work on a project from anywhere, even without an internet connection. In addition to its version control capabilities, Git also has a range of features for managing code branches, resolving conflicts, and integrating with other tools and services. Overall, Git is an essential tool for modern software development and is used by millions of developers around the world. Should newbies to software learn Git? Yes, newbies to software should definitely learn Git. Git is an essential tool for modern software development, and learning how to use it effectively will help new developers to become more efficient, collaborative, and confident in their work. Here are some reasons why newbies should learn Git. Industry standard, Git is the most widely used version control system in the software industry, so learning how to use it effectively will give new developers a valuable skill set that is in high demand. Collaboration, Git makes it easy for multiple developers to work on the same codebase simultaneously, without stepping on each other's toes. Learning Git will help new developers to collaborate more effectively with their peers and contribute to larger projects. Best practices, Git provides a framework for organizing code changes, collaborating with others, and maintaining the integrity of the codebase over time. Learning Git will help new developers to understand and apply best practices for software development. Experimentation, Git allows developers to make branches of code, which can be used to experiment with new features or make changes without affecting the main codebase. Learning Git will give new developers the tools they need to experiment with new ideas and explore different approaches to coding. Community support, Git has a large and active open source community, which provides support, resources, and best practices for using Git effectively. Learning Git will give new developers access to this community and the wealth of knowledge and resources it provides. Overall, learning Git is an essential skill for new developers who want to become more efficient, collaborative, and effective in their work. Is Git free to use? Yes, Git is free and open source software, which means that it can be used, distributed, and modified by anyone without any cost. Git was developed as an open source project by Linus Torvalds in 2005 and has since become one of the most widely used version control systems in the software industry. While Git itself is free to use, there are many services and tools that are built on top of Git that may require payment or subscription fees. For example, many code hosting platforms such as GitHub, GitLab, and Bitbucket offer free and paid plans with different levels of features and support. Additionally, there are many third-party tools and services that integrate with Git and may require payment or subscription fees. However, the core functionality of Git itself is free and open source, and can be downloaded and installed on any computer or server without any cost. This makes Git accessible to developers of all levels, from beginners to professionals, and helps to promote collaboration, innovation, and open source development in the software industry. What is GitHub? GitHub is a web-based platform that is primarily used for version control and collaborative software development. It provides a central location where developers can store their code, track changes to the code over time, and collaborate with other developers on projects. GitHub allows developers to make and host their repositories, which can be public or private, and provides a range of tools to manage and share code. It includes features such as issue tracking, pull requests, code review, and wikis, all of which are designed to support collaboration and facilitate the development process. GitHub is widely used by developers and organizations around the world for a variety of purposes, including open source development, private code hosting, and project management. Its popularity is largely due to its ease of use, versatility, and powerful tools, making it an essential tool for many software development projects. Do big companies use GitHub? Yes, many big companies use GitHub for their software development needs. GitHub is widely used across a variety of industries, including technology, finance, healthcare, and more. Some of the biggest companies that use GitHub include Microsoft, Google, Facebook, and Amazon. These companies use GitHub to manage their code repositories and to collaborate on projects with their development teams, both internally and with external contributors. GitHub's popularity among big companies is due to its powerful tools for managing code, tracking changes, and facilitating collaboration, as well as its large and active developer community. Additionally, GitHub's open source platform allows companies to contribute to and benefit from a wide range of open source projects, which can help them save time and resources in their own development efforts. Do they use it in projects that are not open to the outside? Or are they using it for open source projects? Yes, companies use GitHub for both open source and closed source projects. While GitHub is well known as a platform for open source development, it also supports private repositories, which can only be accessed by authorized users. Many companies use private repositories on GitHub to manage their internal codebase and collaborate on proprietary projects with their development teams. Private repositories offer the same powerful tools for managing code and facilitating collaboration as public repositories, but with the added security of restricting access to authorized users only. In fact, the vast majority of GitHub repositories are private. According to GitHub's 2020 State of the Octoverse report, 72% of GitHub's top 10,000 repositories are private, while the remaining 28% are public. This indicates that while GitHub is widely used for open source development, it is also heavily used by companies and organizations for private, closed source projects. How to write name GitHub. With uppercase or lowercase letters? The correct capitalization for GitHub is with an uppercase G and an uppercase H. How to write Git. With uppercase or lowercase letters? The correct capitalization for Git is with an uppercase G and lowercase it. Are Git and GitHub the same thing? No, Git and GitHub are not the same thing. Git is a distributed version control system that allows developers to track changes to code over time and collaborate with others on software development projects. Git is a command line tool that is typically used locally on a developer's computer. GitHub, on the other hand, is a web-based platform that provides a central location for developers to host and manage Git repositories. GitHub provides a user interface that allows developers to make and manage repositories, collaborate on projects with others, and utilize a range of features such as issue tracking, pull requests, code review, and wikis. While Git is a standalone tool that can be used without GitHub, GitHub relies on Git as its primary version control system. Developers can use Git to manage repositories on other platforms or on their local machine, but GitHub is specifically designed to integrate with Git and provide a user-friendly interface for managing Git repositories. In summary, Git is a version control system, while GitHub is a platform that provides a web-based interface for managing Git repositories. Can you explain it another way? Sure. Imagine that Git is a two-line toolbox that helps you manage changes in your codebase. You can use this tool to make local repositories, track changes, and collaborate with others. It's a powerful tool, but it doesn't provide a way to share your code with others or collaborate online. GitHub, on the other hand, is like a platform or service that provides a place to store your code online and collaborate with others. It's like a virtual workspace where you can store your code and manage its history. You can use GitHub to create repositories, collaborate with others, and manage your codebase. GitHub also provides additional features like issues tracking, pull requests, and wikis to help you work more efficiently. So, in summary, Git is a tool for managing code changes locally, while GitHub is a platform for storing and collaborating on code online. While Git is a powerful tool, GitHub makes it easier to manage repositories and collaborate with others. Give me an example, please. Sure, here's an example. Let's say you're working on a programming project with a team of developers. You're using Git to track changes to the codebase, so you create a local repository on your computer. You use Git to make changes to the codebase, commit those changes, and push them to a remote repository on a server. Now let's say you want to collaborate with another developer who is located in a different part of the world. You can use GitHub to create a new repository online and invite the other developer to collaborate with you. The other developer can then clone the repository to their local machine, make changes to the codebase, commit those changes, and push them to the remote repository on GitHub. You can then review those changes, provide feedback, and merge the changes into the main branch of the codebase. So in this example, Git is used to manage changes to the codebase locally, while GitHub is used to store the code online and facilitate collaboration between developers. Give me another example, please. Sure, here's another example. Let's say you're a freelance web developer and you've been hired to develop a website for a client. You decide to use Django, a Python web framework, to build the website. You use Git to manage the codebase and track changes to the code. As you work on the project, you make changes to the code and commit those changes to your local repository using Git. When you reach a milestone in the project, you push the changes to a remote repository on GitHub. You also use GitHub to share the code with your client and collaborate with them on the project. Your client can use GitHub to review the code, provide feedback, and open issues if they find any problems. You can then use Git to make changes to the code, commit those changes, and push them to the remote repository. This process continues until the website is completed. So in this example, Git is used to manage changes to the codebase locally, while GitHub is used to store the code online and facilitate collaboration with the client. Can we use them in desktop projects? Yes, you can use Git and GitHub with desktop projects as well. While Git and GitHub are often associated with web development, they can be used for any type of software development, including desktop applications. For example, if you are working on a desktop application, you can use Git to manage changes to the codebase locally. You can commit changes to the code, create branches to work on new features, and merge those branches back into the main codebase when you're ready. You can also use GitHub to store the code online and collaborate with others. For example, if you are working on the application with a team, you can create a repository on GitHub and invite your team members to collaborate with you. You can use issues, pull requests, and code reviews to manage the development process and ensure that the codebase remains stable. In addition, using Git and GitHub with desktop projects can make it easier to manage different versions of the application and track changes to the code over time. Give me an example about desktop projects, please. Sure, here's an example. Let's say you're working on a desktop application that helps users organize their photos. You're working with a team of developers and you decide to use Git and GitHub to manage the codebase and collaborate on the project. You create a local repository on your computer using Git and start making changes to the codebase. You can use Git to commit those changes, create branches to work on new features, and merge those branches back into the main codebase when you're ready. You also create a remote repository on GitHub and push the codebase to that repository. You invite your team members to collaborate with you on the project by granting them access to the GitHub repository. They can clone the repository to their local machines, make changes to the codebase, and push those changes back to the remote repository. Using Git and GitHub for the project allows you to manage the development process more effectively. You can use GitHub to create issues to track bugs or feature requests, and assign those issues to team members to work on. You can also use pull requests and code reviews to ensure that changes to the codebase are reviewed and tested before they're merged back into the main codebase. In addition, using Git and GitHub with the project allows you to easily track changes to the codebase over time. You can use Git to create tags to mark specific versions of the application, and revert to previous versions of the codebase if needed. I share some code on YouTube with a nickname 1 Minute Coder. Can I share the text of these codes with users with Git? Yes, you can share the text of your code using Git. Git is a version control system that allows you to track changes to your code, collaborate with others, and share your code with others. To share the text of your code using Git, you would first need to create a repository on a Git hosting service like GitHub, GitLab, or Bitbucket. Once you have made a repository, you can clone it to your local machine using Git, add your code files to the repository, and then push the changes back to the remote repository on the Git hosting service. Others can then clone the repository and access the code files. It's important to note that Git is not a platform for sharing code in the same way as YouTube. Git is primarily used for version control and collaboration purposes. If you want to share your code with a wider audience, you may want to consider posting it on a code sharing platform like GitHub or a code snippet sharing platform like Pastebin or Gist. Is there another version control system that does the same job as Git? Yes, there are other version control systems that can perform similar functions to Git. Here are a few examples. Mercurial. Like Git, Mercurial is a distributed version control system that allows developers to track changes to code over time and collaborate on software development projects. It has many similarities to Git in terms of its functionality and features, but uses a different underlying architecture and commands. Subversion, SVN. Subversion is a centralized version control system that allows developers to manage and track changes to code over time. Unlike Git and Mercurial, SVN relies on a central repository to manage changes, which can make it easier to manage in some cases. Perforce. Perforce is a commercial version control system that is designed for large-scale software development projects. It offers a range of features for managing code, including version control, collaborative code review, and project management tools. While Git is currently the most popular version control system and has a large and active developer community, each of these systems has its own strengths and weaknesses and may be better suited for certain types of projects or organizations. Ultimately, the choice of version control system will depend on the specific needs and requirements of the project or organization. Yes, there are several other web-based platforms that use the Git version control system, similar to how GitHub does. Here are a few examples. GitLab. GitLab is a web-based platform that provides a user interface for managing Git repositories, similar to GitHub. GitLab offers features such as issue tracking, continuous integration, and code review, and can be hosted on-premise or in the cloud. Bitbucket. Bitbucket is a web-based platform that provides a user interface for managing Git repositories, similar to GitHub and GitLab. Bitbucket is owned by Atlassian, the same company that makes Jira and Confluence, and integrates well with those tools. GitKraken. GitKraken is a Git client that provides a visual interface for managing Git repositories. It can be used with repositories hosted on any Git platform, including GitHub, GitLab, and Bitbucket. While each of these platforms uses Git as its primary version control system, they differ in their feature sets, pricing models, and target audiences. Depending on the specific needs and requirements of a project or organization, one of these platforms may be a better fit than GitHub or another Git-based platform. What is Bitbucket? Bitbucket is a web-based platform that provides a user interface for managing Git and Mercurial repositories. It was made by the software company Atlassian and is primarily used for software development projects. Bitbucket offers many of the same features as other Git-based platforms, such as GitHub and GitLab, including code hosting. Bitbucket provides a central location for hosting and managing Git and Mercurial repositories, allowing developers to track changes to code over time and collaborate with others on software development projects. Pull requests. Bitbucket allows developers to submit and review pull requests, which are requests to merge changes to a repository. This feature is useful for code review and collaboration. Issue tracking. Bitbucket includes an issue tracking system that allows developers to track bugs, feature requests, and other tasks related to the development process. Integration with other tools. Bitbucket integrates with many other software development tools, including Jira, Bamboo, and Slack. Bitbucket is available in both free and paid versions, with additional features and support available in the paid versions. It can be used by individual developers or by teams of developers working on larger projects. What are the similarities between Bitbucket and GitHub? Bitbucket and GitHub are both web-based platforms that provide a user interface for managing Git repositories. They share many similarities, including Git-based version control. Both platforms use Git as their primary version control system, allowing developers to track changes to code over time and collaborate on software development projects. Code hosting. Both platforms provide a central location for hosting and managing Git repositories, allowing developers to share code with others and collaborate on software development projects. Pull requests. Both platforms allow developers to submit and review pull requests, which are requests to merge changes to a repository. This feature is useful for code review and collaboration. Include an issue tracking system that allows developers to track bugs, feature requests, and other tasks related to the development process. Integration with other tools. Both platforms integrate with many other software development tools, allowing developers to build and deploy their code more efficiently. While there are many similarities between Bitbucket and GitHub, there are also some differences in terms of their features, pricing models, and target audiences. Depending on the specific needs and requirements of a project or organization, one platform may be a better fit than the other. Why Git is important. Distributed version control. Git is a distributed version control system, meaning that it allows developers to work on code locally and independently, without needing to be connected to a central repository. This makes it easier for developers to work collaboratively and provides a level of flexibility and redundancy in case of network failures or other issues. Version control. Git allows developers to track changes to code over time, making it easy to roll back to previous versions of the code if necessary. This is useful for debugging, testing, and collaboration. Branching and merging. Git allows developers to create branches of code, which can be used to experiment with new features or make changes without affecting the main codebase. Branches can then be merged back into the main codebase when they are ready. Collaboration. Git makes it easy for multiple developers to work on the same codebase simultaneously, without stepping on each other's toes. It provides tools for resolving conflicts and merging changes, and allows developers to review each other's code through pull requests. Open source community. Git has a large and active open source community, which contributes to the development of Git itself as well as many other open source projects. This community provides support, resources, and best practices for using Git effectively. Overall, Git is important for software development because it allows developers to work collaboratively, manage code changes effectively, and maintain the integrity of the codebase over time. What is the difference between Git and GitHub? Git and GitHub are two related but distinct technologies. Here are the key differences between Git and GitHub. Function. Git is a distributed version control system that is used for managing and tracking changes to source code files over time, while GitHub is a web-based platform that provides hosting for Git repositories, as well as a range of collaboration and project management tools. Ownership. Git was made by Linus Torvalds in 2005 and is maintained as an open-source project, while GitHub was made by Chris Wanstraat, PJ Hyatt, and Tom Preston Werner in 2008 and was later acquired by Microsoft in 2018. Access. Git is a command-line tool that can be installed on any computer or server, while GitHub is a web-based platform that requires an internet connection and a web browser to access. Features. Git provides basic version control functionality, such as committing changes, branching and merging code, and tracking file history. GitHub adds a range of features on top of Git, such as issue tracking, pull requests, code reviews, and team collaboration tools. Pricing. Git is free and open source software that can be installed on any computer or server without cost, while GitHub offers both free and paid plans with varying levels of features and support. In summary, Git is a version control system that is used for managing changes to source code files, while GitHub is a web-based platform that provides hosting for Git repositories, as well as a range of collaboration and project management tools. While they are related technologies, they serve different functions and are used in different ways. How does Git works? Git works by keeping track of changes to files and folders in a repository, or repo for short, which is a folder on your computer that has been initialized with Git. When you make changes to files in the repo, Git keeps track of those changes and allows you to review and revert them as needed. Here is a brief overview of how Git works. Initialize a Git repository. You start by creating a new folder on your computer and initializing it as a Git repository using the git init command. Add files to the repository. Once you have a Git repository set up, you can start adding files to it using the git add command. Commit changes to the repository. After making changes to your files, you use the git commit command to create a new commit, which records the changes you made to the files in the repository. Review and revert changes. Git makes it easy to review and revert changes to your files. You can view the history of changes using the git log command, and revert changes using the git revert or git reset commands. Collaborate with others. One of the main benefits of Git is that it allows you to collaborate with other people on the same project. You can use Git to push your changes to a remote repository, such as on GitHub, and pull changes made by others back into your local repository. This is just a high-level overview of how Git works. There are many more advanced features and concepts in Git that you can explore as you become more comfortable with the tool. How does GitHub works? GitHub is a web-based platform that provides hosting for Git repositories, as well as a range of collaboration and project management tools. Here's a brief overview of how GitHub works. Create a repository. The first step in using GitHub is to create a repository, which is a central location for storing and managing your source code files. You can create a new repository on GitHub by clicking the New Repository button on the GitHub homepage and following the prompts. Clone the repository. Once you have made a repository on GitHub, you can clone it to your local computer using the git clone command. This creates a local copy of the repository on your computer that you can work with. Make changes. After you have cloned the repository, you can make changes to the source code files on your local computer using a text editor or an integrated development environment, IDE. Commit changes. When you have made changes to the source code files, you can use the git add command to stage the changes and the git commit command to commit the changes to the repository. This creates a new version of the code with your changes. Push changes to GitHub. After you have committed your changes, you can use the git push command to upload the changes to the GitHub repository. This makes your changes available to other collaborators on the project. Collaborate with others. GitHub provides a range of collaboration tools that allow you to work with other developers on the same project. For example, you can create and review pull requests, which are requests to merge your changes into the main branch of the code. You can also use GitHub's issue tracking system to track bugs and feature requests. Overall, GitHub provides a powerful set of tools for managing and collaborating on software projects using Git. By hosting your Git repository on GitHub, you can easily share your code with others, track changes over time, and work together to build high-quality software. What are the concepts that beginners should know about GitHub? Here are some key concepts that beginners should know about GitHub. Git is a distributed version control system that is used to track changes in code over time. GitHub is built on top of Git, and uses Git's core functionality to provide additional features and functionality. Repository. A repository is a central location where code and other files are stored and managed. In GitHub, A repository is used to store a project's source code, documentation, and other related files. Branch. A branch is a separate version of a codebase that allows for experimentation and development without affecting the main codebase. In GitHub, branches can be made and merged to enable collaborative development and testing. Pull request. A pull request is a request to merge changes made in one branch of a repository into another branch. This is a key feature of GitHub that enables collaboration and code review between team members. Fork. A fork is a copy of a repository that is made in order to allow for independent development and experimentation. Forking is a key feature of GitHub that enables open source collaboration and contribution. Commit. A commit is a snapshot of changes made to a repository at a particular point in time. Commits are used to track changes and enable collaboration and code review. Issue. An issue is a problem or task that needs to be addressed in a project. Issues can be used to track bugs, feature requests, and other development tasks. Markdown. Markdown is a lightweight markup language that is used to format text in GitHub. It is used for writing documentation, README files, and other types of text content. These are just a few of the key concepts that beginners should know about GitHub. As you start working with GitHub, you will likely encounter many more concepts and features that are specific to your project and workflow. Thank you for your answers. You're welcome. If you have any more questions or need further clarification, feel free to ask. Thank you for listening to 1 Minute Coder in ChatGPT.
This is a conversation between 1 Minute Coder and ChatGPT about testing in software development. Testing is an essential aspect of software development. It involves checking whether the software meets the requirements and behaves as expected.
How do I get started with testing?
Well, 1 Minute Coder, the first step is to understand the different types of tests. There are several types of tests, including unit tests, integration tests, and acceptance tests. Unit tests focus on testing individual functions or methods within the code to ensure they work as expected. Integration tests are used to test how different components of the system work together. Finally, acceptance tests check whether the software meets the business requirements and is ready for deployment.
That makes sense. How do I write these tests?
To write tests, you'll need to use a testing framework. There are several testing frameworks available, such as JUnit for Java, PyTest for Python, and Jest for JavaScript. These frameworks provide a structure for writing tests and running them automatically.
How often should I test my code?
You should aim to test your code as often as possible. Ideally, you should have automated tests that run whenever you make changes to the codebase. This way, you can catch bugs and issues early on in the development cycle, which can save you a lot of time and effort in the long run.
What are some common testing tools and frameworks that I can use?
There are many testing tools and frameworks available, depending on the language and platform you're working with. Here are a few popular options. JUnit, a testing framework for Java that provides a simple way to write and run tests. PyTest, a testing framework for Python that supports testing of functions, classes, and modules. Mocha, a testing framework for JavaScript that can be used for both back-end and front-end testing. Selenium, a tool for automating browser testing and interactions. Cypress, a JavaScript-based testing framework that can be used for end-to-end testing of web applications.
Are there any best practices that I should follow when it comes to testing?
Yes, there are a few best practices that you should follow. First, you should aim to write tests that are independent of each other, so that a failure in one test does not impact other tests. Second, you should write tests that are easy to read and maintain, so that other developers can understand what's being tested and why. Finally, you should aim to have a good balance between unit tests, integration tests, and acceptance tests, so that you're testing your code at different levels of abstraction.
How do I know if I've written enough tests?
It's hard to say exactly how many tests you need to write, as it depends on factors such as the complexity of your code and the level of risk associated with the software. However, a good rule of thumb is to aim to have enough tests to cover all the major use cases and scenarios. You should also try to write tests for any edge cases or error conditions that could occur.
Is it possible to test for performance and scalability?
Yes, it is possible to test for performance and scalability. This is usually done through load testing and stress testing. Load testing involves simulating a large number of users or requests to see how the system performs under heavy load. Stress testing involves pushing the system beyond its limits to see how it responds. There are several tools available for load testing and stress testing, such as Apache JMeter and Gatling. These tools allow you to simulate different levels of load and measure the system's response time, throughput, and other performance metrics.
How do I know if my tests are actually effective?
That's a great question. The effectiveness of your tests can be measured by their ability to catch bugs and issues in the code. You should also monitor the code coverage of your tests, which measures how much of the code is being tested. Aim to have a high code coverage, ideally above 80%. You can also use tools like SonarQube or Code Climate to track the quality and effectiveness of your tests.
How can I ensure that my tests are maintainable over time?
That's a great question. To ensure that your tests are maintainable over time, it's important to follow good coding practices, just like you would with your production code. Here are a few tips. Write clear, concise, and readable tests that are easy to understand. Use descriptive and meaningful names for your tests, test classes, and test methods. Keep your tests organized and well-structured, with clear separation between different types of tests. Write tests that are independent of each other, so that a failure in one test does not impact other tests. Regularly review and refactor your tests to ensure they remain up-to-date and relevant. By following these tips, you can ensure that your tests remain maintainable over time and continue to provide value as your software evolves. This is a conversation between 1-Minute Coder and ChatGPT. Hi there. Today, we're going to talk about a programming concept that has taken the tech world by storm, Python. Python is a powerful, high-level programming language that is easy to learn and use. It has become one of the most popular programming languages in the world, and for good reason.
That sounds interesting. What makes Python so special compared to other programming languages?
Well, for starters, Python is very easy to read and write. Its syntax is simple and intuitive, which makes it a great choice for beginners who are just starting to learn programming. It also has a large community of developers who contribute to the language, making many useful libraries and tools that make Python even more powerful.
That's really cool. Can you give me an example of what you can do with Python?
Sure. Python can be used for a variety of things, from web development to scientific computing, machine learning, and more. For example, you can use Python to build web applications using frameworks like Django or Flask. You can also use Python to analyze data and make visualizations with libraries like Pandas and Matplotlib. And if you're interested in machine learning, Python has libraries like TensorFlow and PyTorch that make it easy to build and train models.
Wow, that's really impressive. How can someone get started learning Python?
Learning Python is easy and fun. There are many online resources available that can help you get started, including interactive tutorials, video courses, and documentation. One popular resource is Codecademy, which offers a free Python course for beginners. Another great resource is the official Python website, which has a wealth of information and resources for beginners and advanced users alike.
Do you have any advice for someone who wants to pursue a career in programming with Python?
Sure. If you're interested in a career in programming with Python, there are many paths you can take. One option is to specialize in a particular area of Python development, such as web development, data analysis, or machine learning. You can also explore different industries that use Python, such as finance, healthcare, or e-commerce.
What kind of skills do I need to be successful in Python development?
To be successful in Python development, you'll need to have a strong foundation in programming concepts, such as algorithms, data structures, and object-oriented programming. You'll also need to be proficient in Python syntax and have experience working with libraries and frameworks. In addition, strong problem-solving skills, attention to detail, and the ability to work in a team are all important for success in the field. This is a conversation between 1 Minute Coder and ChatGPT about encapsulation in programming.
Can you explain what encapsulation is in programming?
Of course, 1 Minute Coder. Encapsulation is a fundamental concept in object-oriented programming that refers to the practice of hiding the implementation details of an object and exposing only the necessary interface or functionality to the outside world. It is achieved by bundling data and methods together within a class and controlling access to them through access modifiers such as public, private, and protected.
I see. Do we have to use a class?
Encapsulation is typically implemented using classes in object-oriented programming languages, but it is possible to achieve encapsulation using other mechanisms as well. For example, in functional programming languages, encapsulation can be achieved through the use of closures, which allow the encapsulation of data and functions within a lexical scope. Similarly, in procedural programming languages, encapsulation can be achieved through the use of modules, which allow the grouping of related functions and data into a single unit. However, the use of classes is the most common way to implement encapsulation in object-oriented programming, as it provides a natural way to organize related data and functionality into reusable units. Classes also provide other benefits such as inheritance, polymorphism, and abstraction, which can make code more flexible, modular, and extensible.
I see. Why is encapsulation important in programming?
Encapsulation is important for several reasons. First, it helps to protect the data inside an object from being modified accidentally or intentionally by other parts of the program. Second, it allows for the making of reusable code, since the object's interface can be used without knowing how the object works internally. Finally, Encapsulation can make code easier to maintain and modify, since changes can be made to the object's implementation without affecting other parts of the program.
I see. How does encapsulation work in practice?
Encapsulation is achieved in practice through the use of access modifiers, such as private, public, and protected. These modifiers control the visibility of the data and methods inside a class so that they can only be accessed by other parts of the program through a well-defined interface. By hiding the implementation details of an object, encapsulation helps to keep the code organized and easy to understand.
I see. Can you give me an example of encapsulation in action?
Sure, let's say we have a class called person that has a private field called age. The class also has a public method called getAge that returns the age of the person. By making the age field private and providing a public method to access it, we are encapsulating the data so that it cannot be accessed or modified directly from outside the class. This helps to ensure that the age of the person can only be changed through the proper methods, and that the rest of the program doesn't need to know how the age field is implemented internally.
One more example, please.
A real-life example of encapsulation can be a car. A car can be thought of as an object that encapsulates several components such as the engine, transmission, brakes, and steering. These components are hidden from the outside world and can only be accessed through a well-defined interface such as the accelerator, brake pedal, steering wheel, and gear shift. The car class provides a public interface that allows the user to interact with the car by calling its methods such as start, stop, accelerate, and brake. These methods encapsulate the internal logic of the car and hide the complexity of the underlying components from the user. For example, when the user calls the start method, the car object initializes the engine, checks the fuel level, and sets the ignition switch to the on position. The user does not need to know about these details and can simply call the start method to start the car. Similarly, when the user calls the brake method, the car object applies the brakes by sending signals to the brake pads, which in turn slows down the car. The user does not need to know about the intricate details of how the brakes work and can simply call the brake method to stop the car. Thus, encapsulation in the car class provides a clear separation of concerns between the internal workings of the car and its external interface, making it easier to use, maintain, and extend the car object in the future.
This is a conversation between 1-Minute Coder and ChatGPT about web services. What is a web service? A web service is a software system designed to allow communication between different applications over the Internet. It provides a standardized way for different software systems to communicate with each other using common web protocols such as HTTP and XML. Web services can be used to share data, functionality, and other resources between different applications, making it easier to integrate different software systems together. Can you give me a real use case of web services so I can better understand what you're saying? Sure. Here's a simple example. Let's say you have a mobile app that needs to access information from a database. Rather than building a direct connection between the app and the database, you could make a web service that acts as a middleman. The mobile app could send a request to the web service for the information it needs. And the web service would retrieve that data from the database and send it back to the app in a standardized format. This allows the mobile app to access the information it needs without having to worry about the details of how the data is stored or retrieved. Other examples of web services include payment gateways, weather APIs, and social media APIs. Wait. I like mobile app example. Can I use the same web service on a wristwatch, an airplane, or a submarine? Yes, you could use the same web service on different devices like a wristwatch, an airplane, or a submarine as long as those devices have an internet connection and the capability to communicate with the web service using the appropriate web protocols. For example, a smartwatch app could also use the same web service to retrieve data from a database. As long as it is able to communicate with the web service over the internet using the appropriate protocols. Similarly, an airplane or a submarine could use web services to access weather data or other information from external sources. Web services are designed to be platform and language independent, so as long as the device is able to communicate with the web service using the appropriate protocols, it should be able to use the web service. What are these protocols shortly? In the context of web services, protocols refer to a set of rules and standards that are used for communication between different software applications. Here are some common protocols used in web services. HTTP, a protocol used for sending and receiving web-based requests and responses. XML, a markup language used for exchanging data between different systems. SOAP, a protocol used for exchanging structured data between different systems. REST, a protocol used for accessing and manipulating data on the web. These protocols define how data is sent and received between different systems and ensure that the data is interpreted correctly. By using these standardized protocols, different software systems can communicate with each other more easily and efficiently. Hey ChatGPT, I understand that I can make a database available to thousands of different devices with a web service. I don't care what language they use. It is enough for these languages to be able to use web services. Am I right? Yes, you are correct. Web services allow for communication between different software applications regardless of the programming languages or platforms they are using. As long as the software application is capable of communicating with the web service using the appropriate web protocols, it can access the data and functionality provided by the web service. This makes web services a powerful tool for enabling communication and data sharing between different software applications, regardless of the programming languages or platforms they are using.